Hello and welcome to my 2026 Beginner's Guide to Building a PC, where I'm going to be showing you step by step how to put all the parts I've got in front of me together today to come up with a fully working PC by the end of the video. Not only that, but I'm going to be showing you how to install Windows 11, any drivers or programs you need. I'll be showing you how to install and set up the RGB software. I'll be showing you how to enter the BIOS, update the BIOS and adjust any BIOS settings, including setting up fan curves and overclocking the RAM. Then at the end of the video, I'm going to be showing you how to do some thermal testing so you can test the performance of the system that you've built. So if you've never built a PC before, don't worry, I've got you. I'm going to be taking things really slowly. We'll be assuming you don't have any PC building knowledge at all and taking you through everything step by step and explaining why I'm doing what I'm doing. So let's make a start by taking a look at our case. The case I'm using is from Haven and it's their BF360 Flow Edition, and being the Flow Edition, it comes with pre-installed case fans, so that's one less thing for us to worry about. The reason that I've chosen this case is it is a nice looking case, it's got good build quality, the fans that are installed are of good quality, they're going to run that cool and quiet. We can fit a large premium air cooler in it, which is exactly what I want, and it comes with a GPU support bracket, which is going to accommodate the large graphics card that I want to install. So the first thing that I like to do in any build is prepare the case. And by prepare the case, I mean remove any panels, anything that is going to get in our way during the build. So we've got one screw here holding our tempered glass side panel in place, another screw holding our other side panel in place, and two screws holding our top panel in place. So we'll go ahead and remove all four of those screws. With the screws removed, we can remove our tempered glass side panel. There's a little notch here you can get your fingers into and just pull it backwards, and then we're able to lift the panel up to remove it. Our other side panel is removed in exactly the same way. There's a notch at the back you can get your thumb into, pull the panel out from the top, and then lift it up to remove it. To remove our case's top panel, we simply just need to pull it up. There's a little tab here we can pull straight up, and the panel is going to lift off. Taking a look at the back of this panel, you'll notice we've got an integrated dust filter. It's going to do a good job of keeping dust out of our PC, but we are going to need to remember to clean it from time to time. On the top of the case, we've got a fan stroke radiator bracket. On this bracket, you are able to mount up to 3 120mm fans. 2 140mm fans are actually up to 2 180mm fans, exactly the same as what we have on the front of the case. In terms of radiator support at the top, it's up to a 360 or 280mm radiator. So no matter what you mount, you're going to use this front of the bracket to mount your fans or radiators. If you're using fans and radiators in multiples of 120, you're going to use these slots here to mount them. If they're multiples of 140, it's these back slots here. And if you want to actually mount 2 180mm fans at the top, you're going to have to remove the back bit of this bracket. It's held on with 3 screws. So with the screws removed, this bracket is now free, so we can slide it forwards. We're going to want to get it to the point where this notch here and this notch here line up with the gap in the middle, and that's then going to allow us to lift the bracket up and remove it. And you can see now we're going to have access now to these slots at the back of the case, and it is possible to mount 2 180mm fans at the top. So one of the temptations you want to avoid as a new builder is just adding extra fans in because you can. I don't think we need any additional fans in this case, so I'm not going to be putting anything extra at the top. Remember, extra fans are going to cost you extra money, and they're also going to bring extra noise into the build. And depending on how you set them up, they might not add any extra benefit in terms of temperature. Sometimes extra fans can actually hurt your temperatures. So I think this case is perfect out of the box, and that's one of the large reasons I've chosen this case. So the reason these cases come with removable brackets is it quite often is easier to install radiators and fans to the bracket outside the case and then set the whole thing in at once. The other advantage of having a removable bracket is it's going to give you better access during the build. So we are going to go ahead and remove this bracket, even though we're not installing anything to it. The reason for removing it is just to give us better access to the build. So there's 2 screws at the top holding it in place. So we'll go ahead and remove the screws. So with the screws removed, we can simply pull this bracket forwards. We're going to be able to lift it up and remove it from the case. So we've got our top I/O and we've got a power button. There's 2 USB Type A ports, a single Type C port, and a combined headphone and microphone jack. And what we're going to need to do is plug additional cables in at the back to our motherboards, which are going to allow all these ports to work. So our case's front panel is magnetically attached at the top, so we simply need to grab it, pull it out from the top, and then we're going to be able to lift it up and remove it from the case. Again, on the back of this panel, we've got an integrated dust filter, so remember you are going to need to clean this from time to time. So as I've mentioned, because I've got the Flow version of the case, it comes with 3 pre-installed case fans, and at the front we've got these 2 massive 180mm fans, which are going to bring plenty of cool air into our build. They're set as intakes, they'll be drawing air in through the filtered dust panel at the front, which is going to keep any dust out and bringing plenty of cool air into our build. Because this is the Flow version, there's nothing additional that you can install at the front. The standard version of the case gives you the option to install smaller fans or radiators at the front, but in this case it's just the stock fans at the front. There's no configurable options. But this is exactly what I wanted to do. So taking a look in from the other side, not only are these fans absolutely massive in terms of their 180mm size, but they're also really thick as well. And they're going to do a really good job of providing loads of airflow into our build, but they'll do that at really low speeds, meaning that the PC is going to be really quiet. So we're just going to need to remove some plastic stickers on the back of the fans. And the other thing you'll notice is we've got this large air vent at the bottom. And the idea behind it, it's going to direct the air coming from this bottom fan up and into our graphics card. So we're going to have air coming into our CPU cooler, but also directed up and into our GPU fans. Then at the rear of the case, we've got this 140mm fan, and it is set to exhaust. So it's going to be taking all the hot air that's come from our graphics card and CPU cooler and exhausting it out the back of the case. And if you're getting the version of the case that comes without fans, it is also possible to mount a 120mm fan here. So for me, I think it's going to be completely unnecessary to add any additional fans. We're going to have loads of really good intake from the front of the case, and our single rear fan will do a good enough job of exhausting it, and also some air is going to passively go out the top of the case as well. So in terms of motherboard support, this case supports motherboards up to eATX in size, although I'm going to be installing a standard ATX motherboard, which will fill into this space here. Another important thing to point out, we don't have any additional cutouts to allow a motherboard with back connectors, so you're not going to be able to use one of these in this case. In terms of CPU cooler support, the case offers support up to a maximum height of 195mm, so we're going to have no problem fitting our large premium Noctua cooler in here. At the rear of the case, we've got 7 horizontal expansion slot brackets for installing your graphics cards or other add-in cards. And in terms of graphics card support, the maximum length supported is up to 410mm, so pretty much every graphics card available should fit in this case. And with such larger graphics cards supported, it's great to see that the case comes with a pre-installed GPU support bracket. So we've got these 2 little rubber pads where your graphics card is going to rest down on, and there is so much adjustment of this bracket. So it is rotatable on the bracket itself, and it also can slide side to side. So you're going to want to loosen it up slightly to allow you to slide it. You're going to move it to the position it's sitting perfectly on your graphics card, and then you can tighten around here, just turn it anti-clockwise, and then that's going to lock the sliding position in place, although on this position you still are able to rotate it. It is possible to move it from side to side. There's a little thumb screw at the bottom which you're going to need to loosen, and then with it loosened you're going to be able to move it further back in the case or further forward in the case. Once you've got it into the right position, just go ahead and tighten up that thumb screw. And what you're simply going to do is just slide the bracket up to where it supports your graphics card, and now you'll notice at the back of the case on the other side of the bracket we've got 2 screws, so you can simply tighten those to hold the bracket in place. So just before we leave the front of the case, you'll notice all around our motherboard we've got these little rubber grommets to help bring our cables through, and we do have these cable organizers, so there's these additional bits of rubber that you're going to be able to pull up or down to help organize the cables. So moving to the other side of the case, and you can see we've got loads of pre-installed Velcro cable straps which are going to be great to help organize all our cables at the back. And you'll notice one really nice thing that Haven are doing is they're putting some labels for which cables they recommend routing where, which will be really handy for a first-time builder. Taking a look at the top of our case, you can notice we've got this 6-port PWM fan hub, and our 3 pre-installed case fans, the 2 at the front and the 1 at the back, are already plugged into it. So this is really going to simplify things. We're only going to have to plug 1 cable into our motherboard to control all 3 of the fans. And if you did want to add any additional fans into the build, you've got 3 additional ports here you could simply plug them into. So if we take a look at our fan hub, you'll notice that one of them has a white top to it, whereas all the other 5 ports are black. And Haven have actually plugged one of our case fans into it. The way fan hubs work is you can have multiple fans plugged into it, but the motherboard can only see the speed of the fans from one of the particular ports, and it's this particular port marked in white. So if we were to plug our 3 fans into 3 other ports, they would work okay, but when you look at the motherboard, it would be showing 0 revs per minute because it can only pick up a speed of a fan from this port. So it's really important that we have one of our fans plugged into this port. So out of the box, Haven have done it correctly. We've got one fan plugged into here, and then it doesn't matter which of the other ports we use. The motherboard is going to see the speed of this particular fan when we look at our BIOS later on. And the cables from that fan hub, as well as all our case cables, are down at the bottom, so I'll just go ahead and free these up. So the 2 cables that are coming from our fan hub are this 4-pin PWM cable. So this is going to need to go into a system fan header on our motherboard, and it's going to allow our motherboard to control all the fans plugged into that hub. Now the important thing is that our hub is going to need power, and it has this SATA cable coming from it, and we're going to need to plug this into a SATA cable coming from our power supply. If we don't do this, our hub is not going to have power and our fans are not going to spin. So remember to plug this into a SATA cable coming from your power supply. So taking a look at our other case cables, the first is our front panel connector, and it is going to control the power switch at the top of the case. So whenever you press it, it's going to turn the PC on, and it also has power LED connected to it, so that button is going to light up. We've got this large cable here, which is going to allow the 2 USB Type-A ports in the top of the case to communicate with our motherboard. This is our USB Type-C cable. It's going to allow the single Type-C port on the top of the case to communicate with the motherboard. And we've also got our HD audio cable, which is going to allow the combined headphone and microphone jack to communicate with our motherboard. In terms of drive mounting, we've got 2 drive trays, and in each of these drive trays you are able to fit either a 3.5-inch drive or 2 2.5-inch drives. So meaning in total you can fit either 2 3.5-inch drives or 4 2.5-inch drives. Now I am going to recommend using M.2 SSDs in this build rather than 2.5 or 3.5-inch drives. But later on for completeness, I will show you how to install both a 3.5-inch and 2.5-inch drive using these drive trays. So our power supply is going to go down at the bottom, and we've got these little rubber pads for it to rest on. And the case will accommodate full-sized ATX power supplies up to a maximum length of 200 millimeters. And we're going to be installing our power supply with its intake fan facing down the way, where it can get plenty cool air from underneath the case. And we've got this removable dust filter here, so don't forget about it. You are going to have to clean it as well, and it can simply be pulled out from the back for cleaning. So once you've got your case, the next thing to do is pick your motherboard, and the first thing I want to look at is size. So in terms of size, motherboards range from mini ATX up to micro ATX. We've got a standard ATX motherboard, and this is an eATX or extended ATX. So compared to a standard ATX motherboard, the eATX motherboard is slightly wider, but the same height. You really only tend to find these in premium expensive motherboards packed with all the premium features. You've got more space in these motherboards, so the cooling tends to be better, and there's more space to fit additional features in. For example, we've got an M.2 slot on the side that there wouldn't be space on a standard ATX motherboard for. One step down from ATX is micro ATX. It's actually the same width, but it's a little bit smaller. And these tend to really only come in budget motherboards. You can see looking at this motherboard, the heat sinks aren't quite as good as these other boards. And then we come to mini ITX motherboard, which is smaller both in terms of height and in terms of width. And you would think with a smaller motherboard, everything's going to be cheaper. It's the complete opposite. Everything with mini ITX, it tends to be much more expensive than the standard ATX motherboards, which is the reason I've recommended this platform. So the first thing you're going to want to do is check your case manual to see what size of motherboard you can fit in the case. So our case will actually accommodate an eATX motherboard, but I'm not going to recommend you go out and get one. As I've mentioned, these tend to be high-end premium motherboards with generally more features than what you're going to need for the average build. And spending all your money on a motherboard is not what you should be doing. You're much better going with a middle to lower end motherboard and spending that extra money on your graphics card or your CPU to get the best performance. Now, if we go for any one of these smaller motherboards, it's not going to look great. Obviously, this tiny motherboard is going to be more expensive and it's not going to look good, so that's going to be a bad option. Micro ATX you might think is a good option because you're going to get this motherboard a little bit cheaper than the equivalent ATX motherboard. The difficulty is both motherboards are going to be mounted in the same position at the top, and you're going to have a load of space at the bottom of this motherboard. It will look fine before you plug the cables in, but once you start running cables coming up from the bottom, it's going to look untidy. So unless you've got a motherboard and you're trying not to buy an additional one, my advice would be to pick up an ATX motherboard for an ATX case. So if you're going to go with my recommendation of an ATX motherboard, the next thing you're going to decide on is, do you want to get a back connector motherboard? So you can see how this motherboard looks really clean without any connectors on the front of it. Whereas this standard board has connectors for our power cables, but also all our case and fan cables on the front of it. So it looks okay at the moment, but once you bring all the cables through and plug them in, it isn't going to look as clean from the front as this board. And if you take a look in from the back of this motherboard, you can see all the connectors are on the back of it. So you're not actually going to see any of the cables getting plugged in at the front. So the big advantage of these motherboards are in terms of aesthetics. Downside of these motherboards are that you have limited choice. There's only a handful of these from a few manufacturers. And the other problem is you're going to have a limited choice in terms of cases. So although our Haven case doesn't support back connector motherboards, I still want to tell you a little bit about them in case you decide to go with a different case. Importantly, in a case that does support back connector motherboards, you can of course use a standard motherboard if you prefer. So it is also possible to get a back connector motherboard in a micro ATX size. I just don't have any of those available, but it is important to check the specs of your case, whether it supports just ATX back connector motherboards or whether it supports micro ATX motherboards with back connectors, because the cutouts in the case are going to be in different places. So if you do want to go with a back connector motherboard, you're going to be able to get one from Aorus, Asus and MSI. Now, Aorus and MSI boards are fairly similar. The only cable that you're going to have at the front is a cable going into your graphics card to power your graphics card. Now, Asus have done something slightly different with their motherboards. They actually have GPU power connectors on the back of the motherboard. So you plug your power supply cables into the GPU connectors at the back of the motherboard. And then there's a little extra connector at the front of the motherboard beside the PCIe slot. And if you use one of their special graphics cards, it's going to get power through this connector, so there's no actual cables to plug into the front of their graphics cards. It is still possible to use one of their motherboards with a standard graphics card. In that case, you don't plug the cables into the back of the motherboard, and you simply plug the standard power cables into your graphics card at the front. So two more things to decide on are the color and the manufacturer, and most manufacturers offer a range of motherboards in black and white. If you're wanting to go with a black build, you'll probably have a bit more of a choice than you will with the white parts, and sometimes the white parts do come at a little bit of a premium in terms of price. In terms of manufacturer, I've used a lot of Asus and Aorus motherboards on the channel over the last year, and they've all been rock solid. My advice when it comes to picking a manufacturer is think what you're going to be using for the rest of your components. If you're going with an Asus graphics card, an Asus motherboard probably makes sense. And if you're going with an Aorus graphics card, an Aorus motherboard probably makes sense. And the reason is that one software package is going to be able to control both your motherboard and your graphics card's RGB. What you don't want to do is have a whole range of different manufacturers in the build. It doesn't look quite as well. And when it comes to control and everything, you're going to have a whole load of software running, which is going to be a bit of a headache. So the next thing to decide upon is what CPU you plan on using in your motherboard, because if you're going to go with an AMD CPU, you're going to need to use an AMD motherboard, and if you're planning on using an Intel CPU, you're going to need to use an Intel motherboard. They aren't going to be interchangeable, and we'll cover the CPU more on the next section. So no matter whether you want to go with AMD or Intel, what is important is what socket does your motherboard use. So the latest AMD motherboards use an AM5 socket, so you're going to want to use that with an AM5 CPU. The previous motherboards were AM4 and they used a different type of CPU, so you can't install an AM4 CPU in an AM5 motherboard. Likewise, if we move over to Intel, the latest socket is LGA 1851 and the socket before that was LGA 1700. So you can't pick an LGA 1700 CPU and put it into the latest motherboard. You're going to have to make sure the CPU is compatible with the socket you're going to be using in the motherboard. So in this build guide, I'm going to be showing you how to install the latest hardware in the latest platforms from both AMD and Intel. If you do want to go with older hardware from previous generations, you can check out one of my earlier build guides. So both with AMD and Intel, they have a high-end chipset. On AMD, it is the X870 and X870E. On Intel, it's the Z890. They have a budget-oriented chipset, which is B850 on AMD and B860 on Intel. Big differences between the two platforms. The first is obviously the price. The flagship one is going to have the higher price, and at that price you get more features. And those extra features come because you've got more PCIe lanes on the motherboard. And that means you can have more things like faster Gen 5 storage. You're going to have more drives available for that. You're going to have more USB ports and other features on the motherboard. What I would say is the B850 and B860 chipsets do tend to offer enough features for the average build. So look really closely at the motherboards and see what each of them offers. And you might find actually your money is better spent on the cheaper chipset, meaning you've got more money for your CPU and your graphics card. One thing to mention about Intel is that on the B chipset, you don't tend to be able to overclock your CPU, although you can overclock your RAM, whereas on AMD, you are still able to overclock both your CPU and your RAM on B850. So I think the most important thing to say about motherboards is don't overspend on your motherboard. The difference between the same CPU installed in a budget motherboard compared to a high-end motherboard is going to be a few percent in terms of performance. So my advice is look at the features each of the motherboards offer, find one that you like the look of, that has good reviews, and save your money for more important components in your build. So now we come on to our CPUs, and as we've mentioned, if you're going with an AMD motherboard, you need an AMD CPU that's compatible with a socket, and likewise with Intel. You might have a bit of difficulty comparing the latest generations because you'll find that a lot of the Intel Core Ultra processors seem to have more cores. And this is just a difference between how Intel and AMD have set up their latest desktop processors. So AMD just goes with all cores the same. They're all big cores for heavy lifting, whereas Intel has this hybrid architecture. There's P cores for performance and E cores for efficient. The P cores do the heavy lifting, where the efficient cores do more of the background tasks that require less power. So it is difficult to compare them directly on a core count. So the way I like to look at it is take the efficient cores as bonus cores and look at the P cores that the Intel CPU has, and that will help you slightly compare between the different platforms. The best way to compare them is to look at the benchmarks. What do you want to use your PC for? Is it going to be a gaming PC? Look at the gaming benchmarks, head over to YouTube and the games that you want to play, compare the different CPUs and see the difference between the performance that you get compared to the price that you're going to have to spend. If you're using it for productivity, video editing, Puget Systems is a great source of benchmarks. That's where I go to when I'm building a video editing PC to see the difference between the different CPUs and GPUs that's going to make and help me decide what I go with. So to give you a quick starting point, if you are planning on building a gaming PC, you can probably still get away with a 6-core CPU. Although if your budget will stretch to it, I would recommend trying to get at least an 8-core CPU. It's going to future-proof your PC a little bit, and if you do want to use it for other tasks, for example, a little bit of video editing, it's going to perform better in that. If you're building a PC purely for video editing or other productivity tasks, you're probably going to want to look at going up the cores, but like I say, the benchmarks are going to help you decide what you need to go with. So if you are building a gaming PC, in general, the most expensive component in your build should be your graphics card, and that's where the majority of your money should go. And while I've told you don't overspend on your motherboard, one thing I will say is don't underspend on your CPU, because you could potentially be creating a source of bottleneck. A bottleneck is where one component in the system holds back other more powerful components. You don't want to overspend on your CPU, but you want to make sure you're not creating a bottleneck with your CPU, and you want to have a reasonably balanced system. And I think if you're going with a reasonably modern 6 or 8 core CPU, it should handle a fairly powerful graphics card. And again, as I mentioned, I would probably try and err towards the 8 core CPU if possible. So if you do want the very best in gaming performance, AMD's X3D CPUs with 3D V-Cache are probably what you want to go with if your budget can handle it. And these are without doubt the best gaming CPUs on the market. The downside of these CPUs is pricing, and actually whether that extra price that you're going to pay to get that best performance is worth it. That's going to have to be up to you to decide, again, by looking at the benchmarks. But if you do have deep pockets and you want the absolute best in terms of gaming PC, it's the X3D CPUs from AMD that you should be looking at. So you might be wondering, can I use the latest and greatest CPU with an older motherboard to save myself some money? Well, the answer with Intel is no, because the Core Ultra processors are the first generation of this CPU, so there's only one set of motherboards that are going to be compatible with this CPU. In terms of AMD, you do have a previous generation of motherboards. They're the X670 and X670E and the cheaper B650 chipset. So these CPUs will work in those motherboards with a BIOS update. So that is one way that you can save yourself some money. One issue you may run into is BIOS compatibility, because obviously whenever the B650 motherboards came out, the 9000 series of CPUs didn't exist. So there generally needs to be a BIOS update done before the CPU will work, and you might actually need to flash your BIOS before your PC will work after you've assembled it. But don't worry, I've covered the steps to doing this in another video, and you'll find a link to that video in the description. So we're now ready to start working on the motherboard, and I'm using a B850 motherboard from Aorus. Now this is an AMD motherboard with an AM5 socket, so meaning we're going to be able to use the latest Ryzen CPUs from AMD. So if you're using something different, it is important to check that your motherboard socket is compatible with the CPU that you're planning on using. And in general, I will try to do as much work on the motherboard as I can while we have it on the table, because you've got really good access all the way around the motherboard. Once you put it into a case, your access is much more limited. So I'm planning on installing our CPU, our M.2 SSD, our RAM, and because I'm using an air cooler, we'll actually install the full air cooler on the motherboard. If I'm using an AIO, I tend to install the backplate for the AIO while I've got it on the table, and then install the rest once we put it into the case. If we turn the motherboard over and take a look at the back of it, you'll notice that there's lots of little bits of metal, and these have the potential to scratch your table. So one way to avoid that is just to set your motherboard down on its box and work on it on top of the box. So we're going to make a start by installing our CPU, and our CPU socket is behind this protective bit of plastic. So to open our socket, we're going to need to use this lever. So we're going to free the lever from this catch here. We're going to push it down and out, and then lift the lever all the way towards the center of the motherboard. We can then lift the CPU socket cover up to expose our socket. So with the socket open, you can see all the individual pins that we have on the socket. Now, one of the things we have to be really careful with is that we don't damage these pins. Particularly on an AMD motherboard, these pins are really difficult if they get bent to straighten again. And if you do damage them, it's probably going to be the end of your motherboard. The other thing that you'll notice is we've got a little plastic notch at the bottom and at the top, and they're going to line up with notches in our CPU, meaning that we can only install it in the socket in the right orientation, and we're going to know when it's sitting correctly in the socket, and the gold contacts in the bottom of the CPU are going to line up with the pins. So I'm going to be using one of the latest generation of Ryzen CPUs from AMD. This is the Ryzen 7 9700X, which is an 8-core CPU, so it's going to be perfect not only for gaming, but for content creation. You'll notice that I'm holding the CPU by the edges, and the reason for this is I want to keep my hands away from these gold contacts on the back of the CPU. So I've already pointed out the notches in the socket, and you'll notice that we've got notches in the top and bottom of our CPU, which are going to line up with the notches in the socket. In terms of orientation, you're going to want to insert the CPU in the socket with the text the correct way up. You'll notice at the top left of our CPU, we've got a little gold triangle, and if I rotate things around, the same gold triangle is on the underside of the CPU. Looking at the top of the socket, you notice we've got a little triangle here, meaning that we're going to want to line the gold triangle on the CPU up with this triangle at the top of the socket. But the easiest way to remember is just install it with the text the correct way up on these latest generation of AM5 sockets. With older AM4 sockets, the CPU was installed with the text on the side. So be careful, you can only use this if you're using the latest generation of AM5 sockets. So holding the CPU carefully by the edges, I'm going to lower it down gently into the socket, making sure I'm not going to damage the pins. We've got those notches at the top and the bottom, which are going to line up with our CPU, and they're going to fall down. Now what we don't want to do is push down on this, because if we're not properly seated, we'll put pressure on those pins and damage them. So what I would recommend doing is just very gently moving the CPU from side to side and also up and down. And if it isn't sitting correctly, it will then fall into the socket. So I can see the CPU is sitting fully in the socket. When I move it from side to side and up and down, there's no real movement on it. So at this point, we can go ahead and close our socket cover down again. Now this plastic cover will pop off when we close the lever, so don't be alarmed by this. So we'll go ahead and close the lever down. And as we do, then we'll put the clip in under here. Now in this instance, it didn't fully pop off, only one side has come loose. So we can then lift this up and remove it. Now it's really important that we don't throw this away, because remember, when we take our CPU out of this socket, we're going to need to put this back on to protect those pins. So the best place to put this is inside your motherboard box, so you've got it when you need it. So I also wanted to show you how to install an Intel CPU on the latest platform. So this is an LGA 1851 socket, which is the latest socket compatible with Core Ultra CPUs. And this is a Z890 motherboard. So to open this socket cover, we've got our lever this time at the bottom. Same process, we're going to push it down and out. This time we'll bring it all the way to the top of the motherboard, and our socket's just going to open up the other way round. So you'll notice we've got our pins in the socket, and this is our CPU. It's a Core Ultra 9 285K, and again I'm holding it by the edges, and the reason for that is I don't want to get anything on these gold contacts. You'll notice we've got a triangle on the bottom left hand side of the CPU, but again the easiest way to orientate it is just install it with the text the correct way up. And not the easiest for me to show you here, but we do have a little triangle again on the bottom left hand side of the socket. And again, if I close the cover down, you can see the triangle here. So that's going to line up with that mark on the CPU. The other thing to point out, we've got these little notches at the top and the bottom of the socket over at the right hand side. And again, on our CPU, we've got the notches here and here. So there is only one way that this CPU is going to fit in the socket, and that is going to be with the text the correct way up, and that's the easiest way to orientate it. So the process is exactly the same as on the AMD motherboard. Lower it carefully down into the socket, and it's going to fall into place if you've got things the right way round. The little notches are going to have to line up for it to fall into place. If not, just move it very slightly. So if I have this not installed correctly, so let me just put it here. So it's sitting slightly out of the socket. If I was to close things down in this place, it would push down the pins and damage the socket. So a step you're always going to want to take is just give it a little wiggle from side to side. See how it just fell into the socket there? And now if I wiggle from side to side, it doesn't move. And if I wiggle up and down, it doesn't move, also telling me it's correctly in the socket. At this stage, you can go ahead and close the lever down. Now, I have often found on these Intel motherboards, sometimes closing them can be quite difficult, so I like to get the bit of plastic to pop off first. And if we just push down on this lever, it will pop off, and then we're able to lift it up and again put it in our motherboard box. All we need to do now is close the lever to secure it. So just a matter of pushing it down, sliding it under the little metal clip, and that's our CPU installed. So this brings us on to storage, and I'm going to get straight in with my recommendation, and that is a Gen 5 NVMe M.2 SSD. Three reasons for it. The first is the performance, the second is the price when compared to the older modalities, and the third thing is the ease of installation. So in terms of installation, M.2 SSDs are so easy to install, and I'll be showing you how to install one of these in a minute. They simply slot into the motherboard. There's no additional cables that you're going to need to run. So for a new builder, this is definitely the easiest way to install a drive in your build. In terms of price compared to the older drives, actually all SSDs have got really expensive at the moment. In terms of your NVMe drives, they started off with Gen 3, then we had Gen 4, and more recently Gen 5. And with each generation, the drives have got faster. Last year when I was making my build guide, I had recommended a Gen 4 drive, and the reason was Gen 5s were really expensive. They didn't offer an awful lot in terms of real world performance, so they were massively faster than Gen 4 drives when you ran the benchmarks. Actually, when you look at the moment, the price of Gen 4 and Gen 5 drives are actually pretty similar. So when a Gen 5 is going to give you so much more performance at almost the same price, that's the reason why I'm recommending it. The older SATA drives, they're still pretty expensive. They're not significantly less than an NVMe drive, but the performance is significantly less than even a Gen 3 NVMe drive. One final thing to mention about M.2 drives, particularly if you are looking at the budget end of the market, it is possible to get a SATA M.2 drive. So rather than being NVMe, it is a SATA drive. So it's a slower interface, and it is going to be significantly slower than even a Gen 3 NVMe drive. So just because it's an M.2 drive doesn't mean it's NVMe. Some of the cheaper ones are SATA drives. So as NVMe drives have moved up the generations from Gen 3 to Gen 4 to Gen 5, as well as getting quicker, the drives have been running hotter, and motherboards have been really beefing up their heat sinks to accommodate that increased temperatures. And a lot of manufacturers are now offering drives with heat sinks on them. So I think it depends on the motherboard that you're using. If the motherboard you're using has a really good heatsink on it, I would much prefer to get the drive without a heatsink on it, because it's going to sit in underneath the motherboard's heatsink. It's not going to get in the way of anything, and aesthetically I do tend to think it looks better. And in general, the versions with heatsinks I'm really only picking up if my motherboard doesn't have an adequate heatsink on it. So for our build, I'm going to be using a Gen 5 NVMe drive without a heatsink. Final thing I want to mention before we come on to take a look at SATA drives is that previously I've always recommended installing more than one drive in your system. What I like to do is get a small capacity drive that I install my operating system in, and another drive that I would install all my games library and any video editing files on. And the reason for that is if you were to put them all on the one drive and you fill that drive up, that would then affect the running of the operating system. Or for example, you were doing lots of intensive video editing processes and you were constantly reading and writing to that drive and your operating system was running on the same drive, that may affect your performance. And in general, just separating those two tasks out made sense to me. So that worked really well when drives were incredibly cheap, but like RAM at the moment, the price of SSDs has rocketed. So I've revised my thoughts on that, and I think it's provided you're not going to fill the drive up. For example, you've got a 2 terabyte drive and you're going to leave yourself plenty of headroom and not use that drive to its full capacity. I think you're probably going to be okay installing one drive in your build and having your operating system and your games library and your files running off that same drive. Although if money is no object and you want to get the best performance, I still stand by what I've said in previous videos, and I would generally have at least 2 drives, one for the operating system and one for your video files or your games library. So what about this 2.5-inch SATA SSD? So it's still an SSD similar to what we've got here, but there's a different connection to your PC. So we've got 2 connectors, one's for power and one is for a SATA data cable that plugs into a SATA port on your PC. And the big downside of these is that connection, the moving data to and from the drive, is significantly slower than NVMe. In terms of price, these actually aren't an awful lot cheaper than your NVMe drives, so it's hard to recommend them. The only place they might come in useful if you have limited M.2 slots on your motherboard and need to add more storage in. They're a great way of doing that. But in general, your first choice should be an NVMe drive. So what about a mechanical hard drive? This is a 3.5-inch one, but they also do come in 2.5-inch size. So this works over the SATA interface, the same as the SATA SSD, but it has lots of moving parts in it, which makes it incredibly slow. The other downside is because it's got these moving parts, you can actually hear it and it's quite noisy to have in your PC. Main advantage, however, is it is significantly cheaper than the other forms of storage. Really, the only place it serves purpose for me would be in long-term storage and files that you're not going to have to access that often. And I do have these in my NAS, but it is a separate computer. And I couldn't stand to have this powered on in my main PC because you would hear it over all the fans in the system, and I just can't stand the noise of it. So as far as my thoughts on mechanical hard drives, I wouldn't have it anywhere near my PC because the speed is too slow for what we're getting with the alternatives, and I can't stand the noise. But if you do want to have it in your PC, whatever you do, don't install Windows on it because it will take an absolute lifetime to load and the performance of your PC will be significantly hampered. If you must have one, just use it for long-term storage, but make sure you install Windows on an SSD. Next thing for us to install is our M.2 SSD, and this motherboard has 3 M.2 SSD slots all behind this heatsink. So to remove the heatsink, we need to push this lever up to free it. We can then tilt the heatsink up and lift it back towards us. So our motherboard has 3 M.2 SSD sockets, but they aren't created equally. So it is really important that you have a good look at the manual to identify the speed of the sockets and whether the PCI lanes come directly from the CPU or go via the chipset. So this slot at the top is our Gen 5 slot with the PCI lanes coming directly from the CPU. So it is going to be our quickest slot. The bottom 2 slots are Gen 4 slots, but again, they aren't created equally. The PCI lanes for this middle slot come directly from the CPU, whereas the ones for the bottom slot come via the chipset, so it's going to be a little bit slower than the middle slot. So with our Gen 5 drive, it makes sense for us to install it in the top slot, but if we were planning on installing another Gen 4 drive, we would recommend putting it in the middle slot because the PCI lanes come from the CPU. So one of the disadvantages of Gen 5 drives, although they are faster than Gen 4 drives, is they tend to produce a bit more heat. And you can see we've got this additional heat pad that's going to go below our socket in an attempt to keep our drive cool. So it has some plastic protection on it, which we're going to need to remove. And if we take a look at the back of our heatsink, we've got the heat pads for each of our 3 drives. And again, we've got plastic protection on them, which we're going to need to remove. So a question I'm often asked, if I'm only installing one drive, do I need to move the plastic protection for all the slots? Because this drive is going to be pushing quite a bit of heat and we've got plastic next to it. It probably does make sense to remove it, particularly because our graphics card, which is going to be making quite a bit of heat, is going to be up against it as well. But to be honest, you probably won't get any harm by leaving it on. I'm just going to remove it for completeness. So the M.2 SSD I'm going to be installing is a 2TB Gen 5 drive from Samsung. So next we can take our M.2 SSD and we're going to insert the gold contacts into the socket. So hold it at a slight angle, just push it into place, maybe a little bit of wiggling to get it to go in. And you notice we've got a plastic clip here which is going to hold our drive in place. So all we're going to need to do is push the drive down. We might just need to pull the clip back and then it is going to keep our drive in place. So then we can replace our heatsink. So it's just a matter of lining things up. And once we've got it lined up, we can push it down and the clip is going to hold it in place. So this brings us on to our RAM, and if you're using the latest platforms from both Intel and AMD, it's going to be DDR5 that you want. The previous generation from Intel, some motherboards would use DDR4 and some would use DDR5, but the latest platforms from both AMD and Intel are all DDR5. So like with your motherboard, you're going to have a range of color choices, the commonest being black and white, and you can pick a color that's going to complement your build. The RAM comes both with and without RGB. An important thing to consider is, do you actually want RGB on your RAM? If you're going with a big air cooler that's going to block the RAM, there's probably not much point having RGB on it. Although if you want to move to another system in the future and install an I/O, you may well appreciate having the RGB on it. Another thing to consider is if you are going to have RGB on it and you don't install any software, it's going to run in rainbow mode. And if you want to change it to something, you are actually going to have to use software to control the effects on the RAM. Either your motherboard software, or actually sometimes the RAM manufacturer will have their own package that allows you to adjust the colors on it. But if you do want a PC with the minimum amount of software on it, that's something to consider. You might want to pick RAM without RGB on it. So when it comes to picking a kit of RAM, there's 3 major things to consider. The first is the capacity, the second is the speed of the RAM, and the third is the latency. In terms of capacity, I would recommend a 32GB kit for building a modern PC in the latest platforms. It still is possible to probably get away with 16GB, but how long you can do that, it's going to be determined, and you do probably want to future-proof your PC a little bit. In terms of the speed of the RAM, the higher the speed, the better, and generally the sweet spot is round about 6,000 megatransfers per second. You may get benefits going above that, but again, the price per to performance tends to diminish. And if you are thinking of doing that, it's probably worth looking at the benchmarks to see, is your money better spent here, where it probably isn't, and actually your money is probably better spent on your graphics card or your CPU. Final thing to look at is the latency, and in general, you're probably looking for that to be in the low 30s if possible. The lower the latency, the better. Another thing you might be wondering, is my RAM kit compatible with my motherboard? So most motherboards will have a QVL or qualified vendor list. So you're going to want to check and see, is your RAM kit on that. If it is, you shouldn't have any problem running your RAM at the advertised speed. If your kit of RAM you're planning on using isn't on that list, it's probably still going to work on your motherboard, but you might not be able to get that advertised speed from it. What you do when you put your RAM into the motherboard, it doesn't run at that speed that's advertised on the RAM, and you're going to have to enable either the XMP on Intel or the Expo on AMD to get the RAM running at that faster speed. And if it's not on that list, it's not guaranteed that that is going to work. So you're always better to pick RAM that is on that list. Another thing, when you look at that list, you'll notice that the faster speeds that you tend to get in a kit of 2 sticks compared to 4. And that's why would be my recommendation to go with 2 sticks of RAM. So you want 64GB of RAM, pick up 2 32GB sticks because you're going to probably have an easier time. It's going to be cheaper, as you're going to get that faster speed without any issues. If you do really like the aesthetics of 4 sticks, my advice would be to buy a kit of 4 sticks of RAM. You don't want to buy 2 sticks at one point and then get another 2 sticks and add them in, because they are not guaranteed to run together at those faster speeds. Chances are if you plug the 4 sticks in, they probably will run, but you may run into issues when you try to enable the Expo or the XMP profile, and it may not run at those advertised speeds. Final thing to mention on RAM, if you're going with an AMD motherboard, try and pick up the kit that says Expo on it, and if you're going with an Intel build, pick up the one that says XMP. You still probably will be able to run an Expo kit of RAM in an Intel system and an XMP kit in an AMD system and still get them to run at the advertised speed, but the best way to guarantee it is to pick up the right kit for the right system. Expo goes with AMD, XMP goes with Intel. So this brings us on to our RAM, and the kit I'm using is from Kingston. It's their Fury Beast kit. I've got 2 sticks of RAM, each of 16 gigabytes, giving us a total of 32. So there's a couple of reasons that I have chosen this kit. It is going to be covered by our large CPU cooler, so I've picked a kit purposely that doesn't have any RGB on it. The second thing about this kit is it's really quite thin. It's really low profile RAM, so it's going to sit nicely down beneath our CPU cooler, allowing us to install the fan flush. If we had used a much bigger kit, we might actually have to lift our CPU fan up quite a bit, and in smaller cases it could actually mean the CPU cooler no longer fits in the case. So the kit I've got is a kit of 5200 megatransfers per second, and the latency on it is actually quite high, up at 40. Now this was one of the first kits of DDR5 that I was sent out, and if you were buying one, Kingston do have a similar kit. It's 6000 megatransfers per second, but a much lower latency of 30, so that would be the one that I would recommend, and that's the one that I'm going to link to in the video description. I'm just making use of what I have without buying an additional kit. So because our motherboard has 4 slots, but we've only got 2 sticks, we can't just pick and choose which of the slots we put it into, because we're going to want to install it in dual channel mode to get the best performance. The motherboard gives us a little clue. It's got the first icon here between the 2nd and 4th slot along from the CPU. So these are the ones that we're going to want to install it in. Now in some motherboards you'll have clips on both sides of the slots. On this motherboard it's just at the top. So we're going to open the clip on the 2nd and 4th slot along from the CPU. Next thing to look at is we're going to want to install the RAM the correct way round. So you're going to want to line it up with the slot, making sure that the gap fits up with the gap in the socket. In general, you're going to want to have the good side of the RAM facing away from the CPU and the side with the sticker facing towards the CPU. So you'll notice if I try to insert this into the slot, the gap doesn't line up with the motherboard, and if I pushed it in here, it would actually damage both the RAM and the motherboard. So it's actually this way round that we're going to want to install it. Everything lines up. So what we're going to do is lower the RAM down gently into the gaps at the top of the socket. Check it's the right way round, which it is. And once we've got it all the way sitting down in the socket, we're going to put pressure from both sides and push just straight down. And we're going to get a click, and the slot is going to close at the top, making sure we've got our RAM correctly in. Now, in terms of PCs that don't work when you build them, this is probably the most common reason. People haven't pushed down firmly enough and got the clip to close correctly, and have only partially inserted the RAM in the slot. So take your time installing this, make sure you get a nice satisfying click when it goes in, and make sure the clip at the top is fully closed. Then we can take our 2nd stick, and it's exactly the same process. We're going to lower it down carefully into the slot. Once we're happy it's sitting correctly, some firm pressure, and it's going to clip into place, and checking the clip at the top has closed. So this brings us on to cooling our CPU, and there's 2 main options most people are going to go for. It's either an air cooler or an AIO. And I've done build guides with both on the channel, and I think it really depends what you're looking for. In terms of air coolers, they are much simpler. There's much fewer moving parts. There's no water in it to malfunction and end up over your system. And that's why a lot of people like them. There's these really premium options like I've got here in this Noctua cooler, and there's much more budget options, and you can get these significantly cheaper than what you will get the cheapest AIO. They also tend to be a little bit easier to install. In terms of performance, this is a really premium air cooler, and it probably would be on par with at least a good 280mm AIO, and probably bordering a 360mm AIO. But in general, a 360 or 420mm AIO is going to outperform even a premium air cooler. Another thing that a lot of people don't like about these air coolers is they can block up a lot of the view of your system. You've paid a lot of money for an expensive motherboard, and the large air cooler can block it. And you've got so many more options on AIOs. You've got these fancy customizable screens. You can customize the fans on them, and because they block up less your system, you get a better view of it. But you still can get very basic AIOs. This one from Fantex, there's no fancy software required to run it. It simply runs off your motherboard fan curves in the BIOS, and in terms of the RGB, it's just going to be your motherboard headers that are going to control it. These more fancy ones from Lian Li and companies like Corsair, you're going to need to use their proprietary software to run it. And as well as controlling the lighting and the effects on the screen, sometimes these software packages will actually control the fans and the pump speed, taking over a job that the BIOS had done previously. So these tend to be much more complicated, although like I say, you can get basic options. Now, the one thing I haven't touched on is noise. And when you've got a pump and water circulating through it and 3 fans, these are definitely going to be noisier than these premium air coolers. Now, my goal for the build that I'm doing today, I'm trying to build a PC that doesn't have a lot of fancy flashing lights, has the minimum amount of software, and has the minimum amount of noise. And these large premium air coolers from Noctua, like I say, they're pretty close to a 360mm IO in terms of performance. For the CPU that we're using, we're not going to need that performance to cool it, but we're going to actually be able to cool it at minimum noise levels, and that's the big reason that I've gone with this particular air cooler today. But I do appreciate the aesthetics of this might not be to everyone's taste, so the simplest thing to do if you do want to use an AIO in the system, what I would do is get a 360mm AIO, put it at the top of the case, have it set to exhaust, and I've got loads of installation guides for installing AIO, so take a look at the channel, find an AIO that you like, and you should be able to still follow along to this build guide without any problems. So now we come on to installing our CPU cooler, and I'm going to be using Noctua's NHD15 G2 Chromex Black Edition. So this is the 2nd generation of this cooler. They've improved it from the original, and to be honest, this is far more cooling than what we're going to need to cool our Ryzen 7 9700X. So the reason that I have done this is that this cooler will not even break a sweat keeping our CPU nice and cool. And in doing so, the fans won't have to ramp up that high at all. And to be honest, I don't even think we're going to be able to hear that this cooler is on when our PC is running, which is one of the main reasons I like to use it. It is so quiet, and even when the fans are on, the tone of the fans is really acceptable to the ear. I built a lot of PCs, and in general, the tips that I can give you are pick one that has good case fans and pick a good CPU cooler, because there's nothing worse than building a PC that you can't stand sitting beside because it's really noisy. And one of the big things I'm going to do with this PC is hopefully have it running so quietly that you're not actually going to be able to tell that it's on. And one of the steps to that is really overpowering the CPU cooler so that the fans can run nice and low. And the other thing is picking a really good cooler with really good fans so that you're not going to hear them. And that's the reason I've gone for this. If you don't want to spend so much money on one, you can of course go down to a less powered cooler or one that doesn't have as good components, but you're going to have a slightly noisier PC. So our AMD board comes with these stock clips installed. There's some CPU coolers that will just actually clip on to these clips. The Noctua cooler that we're using doesn't. It has its own backplate. So the first step of installing is removing the stock clips, and they're held on with 2 screws on each side. So again, you're not going to want to lose these, because if you want to change your CPU cooler or want to sell your motherboard in the future, you're going to need these to put them back on. So make sure you put these in your motherboard box for safekeeping so you know where they are. So we're going to want to grab the bag labelled AMD parts, and we're going to take one of these grey spacers and put one onto each corner. Then we've got 2 brackets. You can see one's labelled north with an arrow pointing down towards the CPU, so that's going to go at the top in this orientation. And again, we've got this one labelled south for the bottom with the arrow pointing up towards the CPU in this orientation. The other thing to point out that there's 2 positions each of these brackets can be installed in. The holes labelled 0 are the standard position, and the 7mm one is a 7mm offset position. Now Noctua are recommending using the 7mm offset position for AM5 sockets, and M.4 sockets with Ryzen 3000 and 5000 processors. If you're using older Ryzen CPUs, they're recommending the 0 position, or if you have any compatibility issues in the offset position, then you can switch to the 0 position. So for us, it's going to be using the 7mm holes. So we'll set the bracket into place, and we'll use the long screws to go down through the 7mm hole. Just putting them loosely in by hand first of all, and then again also in the 7mm holes at the bottom. And then we can go and tighten things up with a screwdriver. Not to include this thermal guard with the cooler. So the idea behind this little bit of plastic is to prevent thermal paste spilling down these gaps at the side of the CPU. So making sure you've got it in the correct orientation, it's going to simply fit over the top of the CPU cooler, and that's going to hold it in place. So the whole of the top of the CPU is still exposed, but the little gaps down the side have got some plastic protection on them, preventing thermal paste spilling down and contaminating it. So this isn't something that I've used before, and I think as long as you put the right amount of thermal paste in, you shouldn't have big problems with it, and it cleans off fairly easily, so I'm not going to use it. Now, I've always been a big believer in just a single dot in the middle. Noctua do show 1 dot in the middle and 4 small dots around the outside, but like I say, I've never had a problem with a single dot in the middle, and that's what I'm going to stick with. So for completeness, I do want to show you how to install this on an Intel motherboard, and one of the big differences between our Intel and AMD motherboard is while the AMD motherboard came with the stock clips and a backplate, the Intel board doesn't, and actually there's no backplate installed, so that's the first thing that we're going to need to install. So the first thing to do is assemble our backplate, and how we do it depends on which socket we're installing things on. So there's one way to install it for LGA 1851 or 1700, which share the same mounting holes, and this is what we've got. For older LGA 1200 sockets, you're going to want to install it slightly differently. So what we're going to want to do is take these silver screws and insert them through the bracket. So you can see in this orientation, we've got our little triangle towards the middle, and we've got a gap at the outside. So you've got an LGA 1200 socket, that's the orientation that you're going to want to install it in. For 17 or 1851, which we have, we want the triangle towards the outside. So we can simply flip that around. In this position, you can see the triangle occupies the outside of the socket, and we've got a gap towards the middle. And then once we've got things round the right way, there's a little clip we can put on, which is going to hold things in place. So you can see I've installed the other 3 corners in exactly the same way. Then all we need to do is line the back plate up with the holes in the back of the motherboard, and it should simply then just fall through. Next, you're going to want to grab the bag labelled Intel parts, and then it comes with 2 different spacers. For LGA 1200, you're going to use the black spacers. For 1700 or 1851, like we have, you're going to use the blue spacers. So it's one of these onto each corner. Then we've got 2 of these little brackets. You notice there's 2 different positions it can be installed in. For 1700 and 1851, it's position 2. And for LGA 1200, it's position 1. So for standard cooler mounting, we're going to position these through hole number 2, 1 at the top and 1 at the bottom, with the curve facing out the way. And that's going to install the cooler in the standard orientation, where air is going to be going through the cooler in a front to back direction. If for whatever reason you want to install it in an up and down position, it is possible just to rotate these round. And then you're going to have the fans blowing air from the bottom through the top. But for most people, you're just going to want to install it in the standard orientation. And then in that same bag, we do get these thumb screws, so 1 on each corner. And we do get this screwdriver with the cooler, so we can use that to tighten up the thumb screws. So because our Intel CPU is rectangle rather than square shaped like our Ryzen CPU, if we put a pea-sized amount of thermal paste in the middle, sometimes the tops and bottoms won't get adequate coverage. So for Intel CPUs, I do tend to like doing a little line in the middle. And that's just going to ensure that we're going to get enough thermal paste at the top and at the bottom. Now, to allow us to install our cooler and screw it down, we are going to have to remove the middle fan. So there's this little clip here that we just need to pull out to the side. And we spin it round, there's a clip on the back as well. Once it's been freed up, we are just able to lift the fan up. And it probably also makes sense to remove our front fan as well. Because I have probably really slim RAM, it probably will fit underneath the fan. But just to make for ease of installation, it probably makes sense to remove it too. So we just free up the clips. Another important thing to check is our cold plate doesn't have any plastic protection on it. This Noctua cooler doesn't, but a lot of CPU coolers will have some plastic protection you need to peel off here. One important thing is we're going to want to keep this nice and clean, and don't be setting it down where it's going to pick up dirt before we install it. So we've got two little pins on the brackets, so we can go ahead and carefully lower our CPU cooler down, lining the screws up with those pins. And once we're happy we've got them lined up, we can use the long screwdriver that comes with a cooler to just put things on loosely first of all. So we'll get the bottom on the catch, and then the top one to catch, and then we're just going to tighten each a couple of turns at a time. So next I want to show you why I've picked the RAM kit that I have. So I want to show you the other extreme if I put some really big RAM into place. So this really is one extreme to the other, from a very slim kit to a very thick kit. If we try to install our fan back down on top of this kit of RAM, the fan of course will go on, but it's going to be sitting up really, really high. And if we turn things around from the side, you can see how much of the fan is actually up above the cooler, where it won't actually be doing anything for cooling. The other downside of this is it's going to make our cooler significantly taller. And while this may fit in our large case, if you were at a case that had sort of borderline compatibility, it could mean this no longer fits in the case, despite the manufacturer saying that this cooler does fit in your case because of the RAM choice that you've gone with. So we can see in this position here, we are able to get the fan installed all the way down on top of the RAM, and there's just two wee clips at each side, the same way as we took it off, that we can put on. You can notice that this did have RGB on the top of it. You wouldn't see it anyway with the cooler in place. And you can see here that the fan isn't sticking up that much from the top of the case. So not only is your cooling going to be better because more of the fan is going to be over the heatsink, but you're going to keep your case's compatibility. We can then slide our middle fan down into place, and I'm just going to bring the fan cable towards the top of the motherboard. And we'll lower this one all the way down. Just going to try and get it lined up with our other one. And then just pull the clips back onto the heatsink. And then we'll pull the clip in at the top so that we've got both our fans sitting at the same height. We're going to need to plug both of these cables into our CPU fan header to allow it to control the speed of the fans, and Noctua include this 2-to-1 fan splitter cable. So I'm just going to remove the sticker, and then we just need to line the cables up from our fans. So we've got notches here and notches here, so line them up and push into place. And then we take our second fan cable and push them into place. So this grey fan header at the top is our CPU fan header. So we're just simply going to be able to take the other end of the cable. It's only going to go in one way because of the notches, and push it down into place. Our excess fan cables I'm just going to tidy up with a cable tie, and then we can tuck them in out of the way at the top. So the other thing that Noctua include with this cooler are these two low noise adapter cables. What you're going to do is take the end of the cable coming from each fan, plug it into here, And then this end is going to go into the double splitter cable. It's important you don't plug this into the motherboard header and then the double splitter cable into it. You need one of these for each individual fan before going into the double splitter cable. And what it will do is help reduce noise by reducing the maximum fan speed down. Now, when it comes to Noctua coolers, not something I've ever had to consider. They run so cool and quiet that you can barely hear them. So I don't think these are going to be necessary, provided you've set the fan curves up properly in the BIOS, and I'll show you how to do this later on. So you might be wondering how our CPU cooler is going to work. Well, as our CPU runs, it makes heat, and the more intensive tasks we do, the more heat it's going to generate. And obviously we didn't control that, it would overheat very quickly, and in fact within a matter of seconds. So we've got our thermal paste connecting up to the cold plate of our cooler, and then we've got these heat pipes going up to the fin stacks here. So as heat is generated, it's transported up, and then we've got our two fans here. They are blowing cooler coming in from the front of the case through these two fin stacks. There's one for each of them, and then any hot air is coming out the back, and our exhaust fan at the rear of the case is going to take it out the back of the case. So because we plug both of these fans into your CPU fan header, the speed of the fans is going to adjust itself depending on how hot our CPU is. As our CPU gets hotter, the fans are going to follow a fan curve, which I'll show you how to set up later on, and their speed is going to increase. And the increased speed is then hopefully going to cool the CPU down, keeping the temperature under control. And when the PC is under low load and our CPU is not making an awful lot of heat, the fan speed is going to ramp down because they don't need to work too hard. And the advantage of that is going to keep our PC nice and quiet by not spinning so fast. And I'll cover setting up the fan curves later on in the software setup guide. So we've got two more checks to do before we install our motherboard. If your motherboard has a separate I/O shield, you're going to want to install it into this cutout now before you put the motherboard into the case, because afterwards you're not going to be able to install it. Just take care to make sure you don't cut your fingers, because normally the back of these I/O shields are quite sharp. But if we take a look at our motherboard, you'll see that our I/O shield is attached, so that's not something that we're going to have to worry about. The next thing we're going to want to do is check that all our standoffs are installed in the correct place and there's no unnecessary standoffs installed. So with our ATX motherboard, we're going to have 3 rows of 3 standoffs, so it looks like all the standoffs are in the correct position. And if we take a look at the back of the case, there is a code for where the standoff should be. So anything labelled A is for an ATX or eATX motherboard, M is for a micro ATX motherboard, and I is for a mini ATX motherboard. So if we take a look at the top row, we've got A, M, and I, meaning that the standoff is in a position for any of the motherboards. This one is going to be the same, and this one is going to be in a position for an A and M, so micro ATX and ATX and eATX motherboards, but not a mini ATX motherboard. So it's just important, if you're not familiar with the motherboards, go along and check that all the standoffs are in the A position. So for example, if you were using a micro ATX motherboard, you can see there's 2 additional positions here that you might need to put a standoff into. So it's important that you would line your motherboard up and see where you need to add a standoff to. What would be really important also to check, particularly if you're getting your case second hand and somebody previously been using a micro ATX motherboard, if we were to install our ATX motherboard, which would be installed all the way down at the bottom, and somebody had left the micro ATX standoffs in place, they would make contact with the back of our motherboard, potentially damaging it and potentially shorting it. So you really only want the standoffs in the correct position. So if we take a look at our case accessory bag, you're going to get a bag which has a standoff remover in it. And for example, if we were installing a micro ATX motherboard, we would need to put this over one of our standoffs at the bottom, which we wouldn't be using. We can then put a screwdriver over the top and remove the standoff. We would size up with our motherboard and see which of these we needed to use. So say it was the bottom one, you would simply put the standoff in that position and tighten it up. But obviously this isn't something we need to do for our particular build. These were all in the right place to start off, and this was only a demo that I was trying to show you. But it is important. So your first check is, 1, are all my standoffs in the right place? And 2, is there any unnecessary standoffs that are in the wrong place? And that means a standoff where you don't have a hole. Because had we left this here, it would definitely damage the back of our motherboard. So I'll put everything back to the stock configuration. So another thing you're going to want to check, are any of the standoffs different? And what you'll notice is there's a little bit that protrudes from this middle standoff, and also the middle standoff at the top. And the idea behind these standoffs, the rest are flat at the top. These are going to go through the holes in the middle of the motherboard and help line your motherboard up by holding it in place. And different case manufacturers do things slightly differently. I've seen some cases where this is actually completely solid, a little pin that just goes through, so there's nowhere to put a screw in. In this particular case, it's going to go through the middle holes, but you are going to have to put a screw into it. So this will just help us line our motherboard up when we set it into the case. For this next bit, it's a good idea to lie your case down on its back, and we're only going to stand it up once we've secured our motherboard into place. So what we're going to try is try and line the holes in the motherboard up with the standoffs and the I/O shield up with a cutout at the back. And we're going to know our motherboard is lined up because these two extended bits of the standoffs will go through the middle holes, helping hold our motherboard in place. So there you go, the middle standoffs have gone through the middle holes. You see our motherboard is held reasonably well in place. Then you're going to want to grab the case accessory box and then grab the bag of screws labelled motherboard 3.5-inch hard drive. And we're going to use 9 of these screws to secure our motherboard into place. Okay, next thing to do is get our case cables plugged in. Remember, they're the cables that lets our I/O on the top work and also lets our fan hub communicate with the motherboard. So the first cable that we're going to want to plug in is our HD audio cable. It's the one that lets the combined headphone and microphone jack work, and it goes into this header down the bottom left-hand side of the motherboard. So I'm going to go ahead and pass the cable through the cutout, and we're going to plug it in with the HD audio text facing down the way. And then we'll just pull any excess cable through to the back. We've got some system fan headers down at the bottom of the motherboard. So I'm going to bring the PWM cable coming from our fans through. Now this cable does have little notches on one side, and if we look at the header, there is notches on it as well. So it is only going to go into the header one way round. So we'll go ahead and line it up with the header, push it into place, and again just push any excess cable through to the back. Then we've got our front panel connectors, and they're going to go into this header down the bottom right hand side of the motherboard, and it's the pins over to the left hand side of the header that we're going to want to use. So we're going to go ahead and plug it in with the front panel text facing up the way, and again we'll just push all the cable through to the back. So not all cases it's going to come as a single cable, and in a lot of other cases it will come as separate pins. So I'll show a bit of footage of how you would plug this in if the pins all came separately. So if this is the case, you're going to want to check the diagram in your motherboard manual. So into the top row, into pins 1 and 2 from the left hand side, you're going to plug in power LED positive and power LED negative, and it is important you plug these into the right pins. Next to this, you're going to have your power switch. It doesn't matter which way round it goes, but I generally just plug them in with the text facing down the way. Then moving down to the bottom row, pins 1 and 2 are for hard drive LED positive and hard drive LED negative. And again, it's important the positive goes into pin 1 and the negative into pin 2. And then next to this, you're going to have your reset switch. And again, it doesn't matter which way it goes, but generally I just plug it in with the text facing down the way. Next, we've got our USB Type A cable. That's going to let the 2 USB Type A ports on the top of the case work. And it's going to go into this right angled header here. Now pay real careful attention when plugging this cable in. The pins in this header, it is so easy to bend them, and I have done this before. And if you do this, you're not going to be able to use the ports on the top of your case and potentially might cause further damage to your motherboard. So the first thing to say, we take a look at our cable. You'll notice on one side there's a little notch, and on the other side it is completely flat. And then if we take a look in our header, you'll notice at the front we've got a little notch here. So it is only going to go in one way round. So we're just going to take our time and line it up, making sure we've got things the correct way round. And we're going to make sure we've got things completely straight before we apply any pressure to it. So it's going to just push into place when we have things lined up correctly. But if we didn't and we put pressure, we can actually bend the pins. So take your time plugging this cable in because you can do a lot of harm. This brings us onto your front panel Type C header, and that's going to let the single front panel Type C port work, and it's going to go into this header here. So we can go ahead and bring the cable through the cutout. We'll line it up with the header, and push into place. And we'll get a little click when it goes into place, and then we can just bend the excess cable round through to the back. So this brings us on to our power supply, and the first thing to do is get the right size of power supply. So these are all ATX power supplies, which is the standard one you're going to use in most mid-tower and full-size builds. We've also got an SFX power supply, and this is for mini ITX cases where you don't have enough space to fit one of these larger power supplies. You also get SFXL power supplies, where the power supply is sort of a similar form factor at the back here, but is actually a little bit longer than this SFX power supply. So as a general rule, you don't want to use these power supplies unless you have to. So if your case supports an ATX power supply, this is generally what you're going to want to go with, because they tend to be cheaper, they go up to higher wattages, and you've also got bigger fans, so it's going to run cooler and quieter. These you have to use in small form factor builds when you can't fit one of these, and that's the main reason for using them. Next thing to consider is your efficiency. So the 80+ rating on the power supplies will generally go bronze, gold, platinum and titanium. And as the efficiency rating goes up, there's less wasted energy. More of what you're drawing at the wall is delivered to your PC. The more budget bronze option, you're going to waste a lot more of that energy. It's going to be let out as heat, and your power supply is going to run potentially hotter, and your whole system is potentially going to run hotter, and it's going to cost you more to run your system. But that doesn't mean you should go all the way up for that titanium power supply, because the amount of money you're going to pay to get that, you may not recuperate on your power bills. So there is a sweet spot. One thing I would say to you is do not cheap out on your power supply. If you're going to cheap out in any part in your system, do not do it on your power supply, because it is the part that can set your house, your PC on fire, and you do not want this to happen. So in general, if you really are trying to save money, you can go with a bronze power supply. My advice would be to try to go with a gold power supply if possible. But the most important thing, even more important than the efficiency rating, is get a power supply from a recognized brand. You do not want to find one from a brand that you do not know, because I would not trust that in my house. I would be worried about it setting my house on fire. So always pick a power supply from a recognized brand. If you can, go for one with a gold rating. If you're trying to save money, by all means go with at least a bronze. Another thing to consider is how much power do you actually need. So what I would do is use an online power supply calculator. I tend to use BQuats 1. So I've gone ahead and put the components that I'm using for this build into the power supply calculator, and it's telling us that our maximum power requirements are 654 watts. This doesn't mean that you should rush out and get yourself a 650 watt power supply, because you could potentially running it at 100%. And at those higher levels, the power supplies tend to run hot, they're less efficient, your fan's going to be on making lots of noise, so you do want to allow yourself a little bit of headroom. So you can see this in another system where the power supply option is red, even though it's only 95% off the maximum allowance, and that's because you are going to want to give yourself that little bit of a headroom. So for us, we could probably get by with a 750 watt power supply, but if we wanted to future-proof things a little bit and allow for further upgrades, an 850 watt power supply would probably make sense. So certainly over the last few years, PC components have got much more power hungry, particularly graphics cards. So you might think, should I future-proof my power supply? I'll go for one where the wattage is way more than what I'm going to need, and this will last me for years to come. I certainly think you should go a little bit above what you need to future-proof things for a few years anyway. I would worry about trying to do it for longer than that, because what happens, a lot of the power cables are going to change. We've had the 12 volt high power cables, they've been replaced by 12 volt 2x6 cables. And if you have an older power supply and new cables come out for new graphics cards, you might have to upgrade anyway, although there is some workarounds which we'll come on to talk about. So I would certainly go a little bit above what you need in terms of wattage, but I wouldn't try to future-proof for years to come, because new technology will come out and you probably will have to upgrade your power supply at some point. So what about the ATX standard? Well, the data standard is ATX 3.1, and if I was picking up a power supply now, that is what I would go for. We had ATX 3.0 come out round about the 40 series card launches, and NVIDIA brought out the new 12 volt high power connector on their graphics card. So we needed the 12 volt high power cables to power that graphics card with a single cable. That's an example of this cable, which can carry up to 600 watts of power to your graphics card. And all the graphics cards started shipping with these adapters where the standard PCI cables could be plugged in, and you had a 12 volt high power cable if you had an older power supply. So as well as just having the new connector, the graphics cards were really power hungry with high power excursions. So the new power supplies had to be able to handle up to 200% of their maximum rating for these excursions. So with these power-hungry graphics cards drawing so much power through a single cable, we had issues where the cables weren't being properly plugged in, and that was setting PCs on fire. And this is where the ATX 3.1 standard came in. They made some modifications to those cables to make them safer. And it is now a 12 volt 2x6 cable with the latest ATX 3.1 standard. So if I was buying a power supply from a new PC, it didn't have one, that would be what I would go out and buy, an ATX 3.1, because it includes that latest standard cable for the latest NVIDIA graphics cards, which is going to be reasonably safe. The ATX 3.0 is probably okay if you're careful, you don't bend the cable close to the graphics card, you make sure it's well plugged in. But again, if you're going out to buy a new power supply, why would you buy the older standard that potentially had some problems? I would pick up the latest ATX 3.1 power supply if possible. So another thing to consider when getting your power supply is, do you want a fully modular power supply? So these power supplies here are fully modular, they come without any of the cables plugged in. Big advantage of these power supplies is you're only going to need to plug the cables in that you need. You can leave all the other cables in the box and they're not going to clutter up the bottom of your PC. This is a semi-modular power supply, so the main cables are directly plugged into the power supply and can't be removed, and you can plug in the additional cables that you're going to need. The cheapest option is a non-modular power supply, where basically all the cables are plugged into the power supply and can't be removed. Big advantage of these, they tend to be cheaper. Disadvantage is at the bottom of the case you've got loads of cables that you're not actually going to need. I definitely do prefer a modular power supply if possible, because I think it certainly just gives you a cleaner build without a whole load of cables at the bottom that you're not going to need. But again, you're going to have to weigh in the price versus the performance, and is this worth it to pay extra for? Colour is another important thing to consider. The power supplies do come in black and white, so if you are going with an all-white build, you might want to consider a white power supply. The other thing is, look at the cables that come with the power supply. Although this is a semi-modular power supply, it comes with nice black braided cables, so these look quite good. A lot of the cheaper power supplies, they come with multicolour cables, which are going to look absolutely horrible. And like I say, if you're going with a white power supply, check that it comes with nice white cables, because this is going to really improve the aesthetics of your build. And when you're getting up towards those higher end power supplies, you're getting these lovely premium braided cables. When we're on to cables, make sure that the power supply you're getting has all the connections that you're going to need for your build and the right number of cables. If your motherboard is 2 8-pin EPS cables, but the power supply only comes with 1, are you going to be happy with that, or should you have actually done a bit more research and made sure the power supply was going to meet your demands before you bought it? Another thing you're going to want to check is the length of your power supply and make sure that your case will accommodate it. Most cases will, in their specifications, list the maximum length of power supply you're going to be able to fit in it, and remember to factor in your cables as well. So if you have got a power supply that doesn't have the nicest cables, another option you have is to get some cable extensions. So this is a 24-pin cable extension. We can take the cable coming from this power supply and plug it into it. So the bits that are going to be at the front of the case are going to be these nice black and white cables, and we're not going to see this bit at the back of the case. So it's a really nice way to improve the aesthetics of your build. Downside of this is you have massively increased the amount of cables at the back of the case, and cable management can be quite difficult, and you might struggle to get your side panel back on again depending on the case that you've gone for. So again, these are going to cost you extra money, extra headache with cable management, but is it actually going to be worth it in terms of the aesthetics? And a set of cable extensions will maybe cost you anywhere from £30 to £60 depending on the type that you're going for. So just by spending a bit of time making sure you've got nice cables with your power supply, you can save yourself a bit of a headache and a bit of money. So this brings us on to our power supply, and I've got a 1200 watt platinum fully modular power supply from Lian Li. This is an ATX 3.1 power supply, so it's going to come with the latest 12 volt 2x6 cable, so we have nothing to worry about here. And I'm using a 1200 watt power supply because that's just the one I have on hand. They do make this in an 850 watt power supply, so that would be the one that would be perfect for the system that we're building. So giving you a quick look at our power supply, this is the power supply's intake fan, so it's going to draw plenty of cooler in through this fan to cool the power supply down. So it is important that we don't obstruct this fan, and we're going to want to install it facing down the way where we can get cool air from underneath the case. And this is the back of our power supply. It's going to be sticking out the back of the case, and all the air that has been heated up by cooling the power supply down is going to be exhausted out of the back of the case, so it shouldn't mix with our other components in the case. Our wall cable is going to go into here. This is the switch for turning our power supply on and off. but we've also got another on-off switch, and this switch is controlling the eco mode on our power supply. So in the current off position, whenever our power supply is under low load, the power supply's intake fan is not going to spin up. And this is great because it's going to help reduce idle noise. If you'd rather the intake fan spins all the time, you can simply switch to this to on, but my recommendation would be to leave it in the off position to help reduce idle noise. So as I mentioned, we've got a fully modular power supply, which is great because we only need to plug in the cables that we're going to need. So our 24-pin motherboard cable, which is going to power our motherboard, is going to go into these two headers here. We've got a 12-volt 2x6 cable to go into here. This is going to power our graphics card through one cable, which is great. If you've got an older NVIDIA card or you're using AMD, it doesn't use this cable, and you might need to use the standard PCIe cables, which are labeled here. Now these cables can be used interchangeably for CPU and PCIe. We are going to need to use two of the CPU cables to power the EPS ports at the top of our motherboard, and what they do is provide additional power to our CPU. And then we've got these peripheral and SATA ports, and we are going to need to plug a SATA cable into this to power the fan hub in our case, and also because I am going to show you how to install a SATA drive. Again, it's not something I'm recommending, but I'm showing it for completeness in this build. I much prefer just using all M.2 drives in my own systems. Okay, so we'll take our 24-pin motherboard cable, and we're getting a nice click as it goes in. There we go. So this is what the other end of that cable looks like. So we're also going to plug in two UPS cables to provide additional power to our CPU. You'll see that they are labeled CPU, and this is the end that's going to go into the motherboard. We can pick any of these 5 ports to plug them into. So on our motherboard, we've got an 8-pin header, so this cable will go into it. But we've also got a 4-pin header as well. And what we can actually do is just split this cable. So if we put it like this, the cable is going to split into 2. So we're only going to need to plug one of these cables in to fully power our CPU. Now say you've gone for a different power supply and there only is one 8-pin EPS cable, but your motherboard has an 8 plus a 4 like we do, or some motherboards will have 2 8-pin connectors. Well, you don't need to worry about that. Your PC will still run. You can power most CPUs under normal loads with one 8-pin cable. And it really is only for really power-hungry CPUs or CPUs that you're overclocking that you might need more power than what one of these cables can deliver. My general rule is if my power supply has enough cables, I'll tend to fill all the EPS headers at the top of the motherboard. So then we've got our 12-volt 2x6 cable to power our graphics card. You'll see it's got 600 watts, so this one cable can provide up to 600 watts of power to our graphics card. Now you might have heard about all the problems with these sort of cables and GPUs going on fire. This is why the power supplies have been re-revised to the ATX 3.1 standard, and we've now got a 12-volt 2x6 cable rather than a 12-volt high power cable. And when they looked at it, they found one of the major problems were that people weren't plugging these cables in all the way. So that's why Lian Li have color-coded this in blue. So if you see any blue after you plugged it in, it means you haven't plugged it in all the way, both on your power supply and your graphics card. So we go ahead and line this up and push it into place. And we can see that all the blue has disappeared, so that's been plugged in correctly. Okay, last cable to plug in is our SATA cable to power both our fan hub and the SATA drive that I'm going to show you how to install. And it's got 4 of these L-shaped connectors on it, and we can use any one of these 4 ports to power either a drive or a hub. So we've got these ports labeled peripheral and SATA, so we can pick any one of these 4 ports to plug the cable into. Next, we can insert our power supply into the case, remembering to install it with our intake fan facing down the way. So we can just lift these excess cables up out of the way, slide the power supply into place, and then we'll slide it all the way to the back of the case. Next, from the case accessory box, we're going to grab 4 of the screws labeled power supply installation, and we'll use these to secure our power supply into place. So we've got both an 8-pin and a 4-pin EPS cable at the top left of the motherboard, and these are going to provide additional power to our CPU. So we'll just route the cables through the cutout at the top, and we'll line them up with the header and push into place, and then just pull any excess cable out of the way. And then we'll bring a 4-pin connector through, line it up and push into place. And again, just pull the excess cable through to the back. So our 24-pin cable is going to go into this header here, and it's going to power pretty much everything on our PC. We're going to get supplemental power to our CPU with the EPS cables, and a small amount of power is going to be given through this cable to our PCIe slot for our graphics card, but our graphics card is going to get most of its power through that 12-volt 2x6 cable. So we can go ahead and bring the cable through the cutout. Now you'll notice we've got a little clip on one side of this cable, and on this side of the header there is a little notch. The other side is flat. So we're going to want to have the clip facing the right hand side of the motherboard. So we'll go ahead and angle the cable around, line it up with the header. And once we've got everything lined up, we can push it into place. Now what is really important with all these cables, we're going to want to make sure we plug them in fully. But as we haven't plugged them in fully, our PC isn't going to work. So take your time to make sure the clip is closed and we've got a good connection. So you can see we've got a couple of cable combs, which is going to help organize the cable. So we can just simply pull these back a little bit to make the cable look nice and tidy. Okay, last thing for us to do is to plug the SATA cable coming from our fan hub into any one of the 4 ports coming from the SATA cable from our power supply. So it is an L-shaped connector on both, so just make sure you've got them lined up the correct way and then simply push them into place. And remember, if you don't plug this cable in, your fans are not going to spin. Okay, next thing to chat about is fans, and fans over the last few years have got really advanced and really complicated, which is why I'm probably going to spend quite a bit of time here. So the reason I picked the cases that I've gone with is you don't need to do anything additional to them. They're already plugged into the motherboard. We're going to do a bit of customization of the fan curves later on, and I'll show you that. But there's nothing extra to add in or nothing complicated to think about in terms of the airflow. What I will do is spend quite a bit of time talking through how the fans work, how the airflow in the case works, should you want to deviate away from things. But if you're happy with the build as it is, just skip to the next section. So I'm going to start off with some older fans because that's going to make things a little bit easier to understand. You're going to see the problems and then you'll understand why fans have evolved the way they have over the last few years. So this is a non-ARGB fan. Because it's non-ARGB, it's just got one cable coming from it, and it's got a 4-pin connector on it, which means we're going to be able to run this in PWM mode. So PWM stands for pulse width modulation. So how that works is we apply 12 volts to the fan all the time. We're not adjusting the voltage, but we've got an extra pin compared to a standard 3-pin fan connector. And what that extra pin is controlling is the on and off signal. So it's how long does that 12 volts being applied to the fan. If we get the full 12 volts, the fan runs at full speed all the time. If it gets no volts, it doesn't spin. And obviously the longer that signal is turned on, the faster the fan will spin. So there's very quick pulses, so it's on, off, on, off, on, off, and the longer it's left on for, the faster the fan spins. So that's a really nice way to control the fan. You don't have to do that, you can control it using voltage. So in the voltage curve, you're able to pick the voltage you want applied to the fan. And depending on how much you turn the voltage up, the faster the fan will spin. The less voltage, the slower it will spin. The downside of using voltage is the minimum speed of the fans is much higher with voltage control compared to PWM. And that's why people prefer the 4-pin connectors in PWM, because you can get the fans running nice and quiet at idle when you don't need them running faster. The standard 3-pin connectors using voltage control, you're going to have to run them much faster than what you need to at idle. So for that reason, I always recommend 4-pin connectors, running them in PWM mode, because you're going to reduce the idle noise in your build. And in general, if a case manufacturer includes 3-pin connectors in it, I'm going to criticize it in the review, because it only costs a tiny amount of extra money to get the 4-pin connector, and it's going to significantly reduce the idle noise in your build. If you do have 3-pin connectors, what is really important is that we must run that in voltage mode, DC mode, in the motherboard BIOS. If we leave it at PWM mode, what we will do is apply 12 volts to that fan all the time. It will be missing the extra pin that the motherboard will be sending the on-off signal to, so it will never be turned off. So it will get 12 volts all the time and run at full speed. So if you have a 3-pin fan connector, it's really important that you run it in DC mode or voltage mode in the motherboard BIOS. So a lot of motherboards will detect whether you've got a 3 or a 4-pin connector in, and they'll use the auto detect mode to enable the right fan curve, either PWM or DC mode. But you can just confirm that they are running at the right speed when you go into the motherboard BIOS. And if you turn your PC on, it's got lots of 3-pin connectors and they're all running at 100%, the chances are you're running PWM mode in the BIOS. And if you switch them to voltage control, the idle noise is going to come down significantly. Okay, so that's your standard fans, no RGB, one cable, fairly simple to install and fairly simple to control. So over here we've got a standard ARGB fan. So you can see we've got still the power connector, and this is a 4-pin PWM connector here. But you'll notice we've got a daisy chainable connector here, so we can plug the PWM connector from the next fan into here, meaning we have just one connector to plug into our motherboard. The other connector coming from it is a 3-pin 5-volt ARGB connector, and that is going to give us addressable RGB. So it means we're going to be able to display lots of different colors on the fan at once rather than having to go with a static color. You probably noticed in some of the motherboards you've also got a 4-pin 12-volt non-addressable header. These were older connectors, and again I don't have any of these fans left to show you, but you can only display one color at a time on those fans, and they have generally been replaced with ARGB connectors. Again, ARGB headers on the motherboard are limited, similar to your PWM headers, so a lot of fans will have an additional daisy chainable connector, so you can take the connector from the next fan, just line them up and plug them in, and that means you're going to be able to use one header on the motherboard to power multiple fans in terms of the lighting and adjust them using your motherboard software, and again with PWM. So as a general rule, if you are daisy chaining fans into your motherboard header, I don't like to do any more than 3 into any one header. You can go in and look at the voltage available in the headers and see can you push things a little bit harder, but in general 3 fans to any one header is a simple rule to remember. So if you don't have enough headers in your motherboard and your fans don't have these daisy chainable connectors, what you can get is a fan splitter cable. So this is a PWM splitter cable. It's got 3 ports in it, and what you would then be able to do is take your fan connector and plug it into the cable, and then plug the other end into the motherboard, allowing you to plug 3 fans into any one header. So this doesn't need additional power because the fans are powered directly from the motherboard header, but it's important that you don't overload it. And that's why generally these come up to 3 fans in one go. You're not going to find these with 5 or 6 fans plugging into that motherboard header. If you do want to plug more than that into any one header, what you will get is a fan hub. Quite often you'll get these up to 10 ports, but they will need additional power because they can't take all that power from that motherboard header. And in general, you'll find a SATA connector coming from them. You're going to need to plug that SATA connector into your power supply to power the hub, and the PWM cable go into your motherboard. All that does is send the signal from the motherboard telling the fans what speed to run at. Similarly with the ARGB, you can get the ARGB splitter cables. So you're going to be able to plug multiple ARGB devices into one header. Again, if you want to have loads of ARGB devices been controlled in one device, it tends to be what we call a hub, and that hub is going to need additional power. And the ARGB cable going to the motherboard, all it's doing is bringing the ARGB signal to the hub. It's being powered by SATA, and then that's then controlling all the devices, because if you have too many devices, it's not going to be able to draw all that power from the ARGB header. So one of the downsides of bringing ARGB into the build is you're going to have to use some sort of software to control it, and in general that's going to be your motherboard's ARGB package. Some people don't like doing that because then again you're going to have software running in the background when your PC is running and it can use some resources. So an alternative is to get an ARGB controller. So this is a fairly basic ARGB controller. You're going to plug your ARGB device into here. There's a little button that you can press to cycle through the ARGB effects. It's going to need power, which is SATA power, and this means then you're not going to have to use your motherboard software, but you're going to be able to have ARGB in your build if you want. So the other important thing to address is the direction of airflow through the fans, and previously this was very easy to determine. You had a good side of the fans with potentially some writing on it, you could see the fan blades. You had the back of the fans where you had the text and you had something blocking the blades. So air generally went through the fans from the front to the back. So if you were looking at the good side of the fan, air was being taken in and pushed out the back. This was fine if you had this at the front, you had the good side on display. If you're going to have it exhausting at the top, again, you had the good side facing into the case, exhausting at the rear, the good side. The problem came if you wanted to have intake on the side. This did not look very well facing into the case, or intake from the bottom. Again, this did not look very well facing up to the bottom. And again, it's exactly the same with this side. It doesn't look particularly good. So the main problem with this type of device is each fan had its own PWM and RGB cable, meaning you had loads of mess of cables at the back, and the fans had to be installed separately. So how things changed was that a lot of fans came where you were able to join them together. These are example of Lian Li Uni fans, and they simply clip in together. You're going to have one set of cables at the end to control up to 3 or 4 fans. There is certain fans where at the end you're just going to have a PWM and RGB cable, so you're going to be able to run those through your motherboard software. Although what's becoming more common with the fans is you're going to plug them into a hub. That hub is connected by a USB cable into your motherboard. And remember, anytime you hear a USB cable, you're going to have to use some proprietary software to then control the effects on those fans. So the big advantage of this, fewer cables, you get much more lighting effects. You're able to control lighting effects on different bits of the fans. Lots more customizable options, but the downside is you're going to have to run software to control the effects on these fans. And then we've got fans that actually have screens on them. So you can have 3 different lighting effects on the fans, a screen in the middle where you can play videos, pictures, or display your system information. But again, the big downside of these is the cost, and the other big downside is having software running all the time. But they do look absolutely stunning when you put them into a build. So initially when these fans come out, they still shared the same problem, whereas the back of the fans didn't look very good. So if you had this at the bottom of the case set to intake, this was the side was on display, so it didn't look great. So what they've done now is a lot of the fans have reverse fan blades. So when the fan turns in this orientation, it's actually drawing air in the back of the fan and into the case. So if you had this at the bottom, you would have the good side of the fan on display. So that's just a quick run through the fans. I can't cover everything. Every manufacturer has brought out different variations of fans, but it just gives you an idea of what you should be looking for when you're installing additional fans into a build. So as I mentioned, I will show you how to install a SATA drive in case that's what you want to do. But unless you've got SATA drives lying about, I would recommend buying an NVMe drive. So we've got 2 drive trays, and in each drive tray we've got the option of mounting either 3.5-inch or 2 2.5-inch drives. The 3.5-inch drive is going to go in this back bit of the tray, and to install it you are going to have to remove the front bit, which houses 2 2.5-inch drives. So you can't do both. You can either just have the 3.5 or you can have 2 2.5-inch drives. So I'll show you first of all how to install a 3.5-inch drive. So to do that, we're going to first of all need to remove the 2.5-inch drive bracket. So there's a thumb screw at the top. So with it removed, we can then lift the 2.5-inch drive bracket up and remove it. And this is going to leave us with the 3.5-inch drive bracket. It's held on with this screw at the top. And you can see the little metal pads and rubber grommets we've got here. So all we're going to need to do is slide this up, and once it's slid up, we can pull it forward to remove it from the case. So just before we install our drive, I want to show you how we're going to connect it up to our PC. So we've got 2 separate L-shaped connectors. This L-shaped connector is our SATA power cable, and this one, a shorter one, is our SATA data cable. So we're going to put a cable similar to what we plugged into our fan hub into here to power the drive. And we're going to plug a SATA data cable, which comes in our motherboard box, into this one and connect the other end to our PC, allowing the drive and the motherboard to communicate with each other. So in our motherboard box, we get 2 of these SATA data cables. We've got one of them that has a right angle connector on one side, and the other that is just 2 straight connectors on it, but they're going to work exactly the same. So we just need to make sure we've lined the L's up the correct way and push into place. If I just turn things around, you'll notice this has a little lock on it, and you're going to have to push this little bit of metal to remove the cable. And the power cable is exactly the same as what we plugged into our fan hub. Just line the cable up, making sure you've got the L the right way round, and then push down, and it's going to lock into place. Now, I wouldn't normally power the drive up before installing it. The reason I've just done it here is to give you a better look at these connectors. And if we take a look at our 2.5-inch drive, it's exactly the same connectors, We're going to have to put this right angle somewhere, so we'll just plug it into here. And then we can bend the cable up and run this to the front of the case. And then we can use another connector on the same cable coming from our power supply and plug it into here, and we'll power both the drives with the same cable. So I'm going to show you how to install the 3.5-inch drive in this top drive cage. Remember, at the top is secured with the screw here. So we're going to want our drive's I/O coming out at the bottom. So we'll set our drive into the cage this way round. Then we're going to use the same screws that we secured our motherboard to the case with, because they're also for securing 3.5-inch drives. And you can see our drive has 4 screw holes which have lined up here. So we'll secure the drive to the cage with 4 of the screws. And then we can return the drive cage to the case, just line the holes up with the holes in the rubber grommet, and then as we pull down, it's going to lock into place. And then we can re-secure it with the screw removed earlier on. So I'll show you how to secure a 2.5-inch drive in the bottom cage. So we're only going to need to remove the front 2.5-inch drive mounting bracket, and we'll leave the 3.5-inch drive cage in place. So just this top thumb screw to remove. And then we can slide things up and remove it from the case. Okay, so this is our 2.5-inch drive mounting bracket. We've got these little pins on one side, and they are going to go into these holes on the side of our 2.5-inch drive. Again, I'm going to secure it with our I/O facing down towards the bottom. It's just a matter of lining the drive up with the holes, pushing into place, and when it does, that's going to allow us to slide our drive down. Then we're going to want to grab 2 of the screws labeled 2.5-inch SSD Installation, and we'll secure the drive to the bracket with 2 of the screws. So if I go ahead and turn our bracket over, you'll see on the other side it is possible to mount another 2.5-inch drive. So it's just going to be exactly the same process. Line it up with the holes on the side. The drive's going to fall into place. And then you're going to use another 2 of the screws to secure it into place. And if you take a look at the bottom, you're going to have access to the I/O for both of the drives from the bottom. So I'm just going to go with one drive, so we'll take the second one out. And then we'll return our 2.5-inch drive bracket. Just a matter of sliding it into place and pushing down. And then we can replace the thumb screw. So next we just need to plug in our cable. So I'm going to take the right angle SATA cable and we'll get it lined up. Now I'm not going to get you good shots of this, which is the reason I showed you outside the case. And you might just want to plug your SATA data cable in outside the case. So there we go, that's it plugged in. And then we'll plug into our 3.5-inch drive. The other ends of the cables I'm just going to pass through into the main body of the case. And then right above our USB Type A cable that we plugged in, we've got 4 SATA ports. So we can just pick or choose which one we want to go into. And we'll take our cables, line them up and push into place. We're also going to need to power our drive, so we'll take the SATA power cable that's already plugged into our fan hub and we'll take another port and plug it into the drive. That's it, clicked into place. And then we can take another connector coming from that cable and plug it into our 2.5-inch drive. So that's how you install both 3.5-inch and 2.5-inch drives in this case if you want to. But remember, if you don't own any of these, my advice is pick up an NVMe M.2 drive. What I'm going to do, I'm going to leave the 2.5-inch drive in place because it is useful for me to have 2 drives installed, because when you install Windows, only 1 drive is going to show up, and I need to show you the steps to get all your other drives to show up. I'm going to take this 3.5-inch drive out. I hate these in my build. They run really noisily and I can't stand them. So we'll take this out and I'll leave this one in. So this brings us on to the most exciting part of any PC build, and that is the graphics card. And if you're building yourself a gaming PC, this should be the most expensive component in your build. If it's a video editing PC, it depends what package you're using. I use DaVinci Resolve, where you get a big benefit from having a good graphics card. There's other packages where your graphics card doesn't really do that much lifting, so there's no need to spend on like the most expensive one. So what I would say is look at the tasks you're wanting to use the PC for and look at the benchmarks. If you're using it for gaming, look at the games you want to play, look at the different benchmarks in terms of the frame rates that you're going to be getting from it, look at the monitor you're using, what resolution are you going to be using, how fast will that monitor go, and are you actually going to see any benefit by spending a fortune on a graphics card. Again, if you're using your PC for content creation, Puget Systems is where I would go to. Look at the difference the graphics card will make to your workflow, and that's going to help you decide how much you should be spending on one. So in terms of the manufacturers of the graphics card, there's three big players that there: NVIDIA, AMD, and Intel. So when you're trying to decide between the manufacturers, some people do have brand loyalty. They'll only go with NVIDIA, they'll only go with AMD. What I would say is look at the benchmarks, look at the features each of the graphics card offers, and look at the price to performance, and use that to help you make your mind up. When it comes to the power cables, there's really only the high-end and mid-range NVIDIA cards that are using those 12-volt high powers or 12-volt 2x6 cables. If you're going low-end NVIDIA, AMD or Intel, you're generally using the 8-pin PCIe cables, so that may be something to look at when you're trying to pick your power supply. Just remember, if you are using those standard PCIe cables, or if you're using standard PCIe cables to plug into an adapter that comes with your graphics card, try not to daisy chain them. You should be using a separate cable from your power supply for each port on the adapter, or into each port on the graphics card if at all possible. So certainly a trend in graphics cards over the last year is they have just been getting bigger and bigger. So a feature you may want to look at in the case is a GPU support bracket, but thankfully most of the graphics cards will include a GPU support bracket in them. So I'll show you how to install those later on. And the final thing I want to cover is mounting your graphics card vertically. It gives you a great look at the fans on the side of the graphics card, but it does come at extra cost, and there's a few things to be careful about. In terms of how you do it, in some cases you will be able to rotate the PCI extension slot brackets round, turning them into a vertical position. All you're going to need to do is pick up a riser cable to plug into the bottom of your graphics card. In other cases, you're not going to be able to do that, so you're going to need a bracket as well as a riser cable. The other thing you're going to have to be really careful with is what generation of PCIe cable you get. So if you're using the new 5000 series graphics card, you're going to need a Gen 5 riser cable. And if you're going to be using the 4000 or 3000 series graphics card, it's a Gen 4 riser cable that you want. And the final thing to mention, if you are thinking about your graphics card vertically, make sure the fans in the graphics card are well enough away from the tempered glass panel. If they're right up against the tempered glass panel, they might not get enough airflow and the graphics card can run hot. So we're now ready to install our graphics card, and there is a simple rule to remember about installing your graphics card. Although you will have other slots that look like you can put a graphics card into it, you need to put your graphics card into the top slot to get the fastest speed from it. If you install in the lower slots, first of all, you're not going to fit because it's a really thick graphics card, but the speed will be significantly reduced. So how you open the clip on the slot varies. Some motherboards will have a little clip here, but the problem is once your graphics card's installed, and with a big air cooler like this, you're going to struggle to press it. So Aorus have thought about this, and they've got a little button over to the side. It's more for removing your graphics card than installing it. And you're going to press this button, and when you press it, you'll notice the clip on the top slot opens. Next, we're going to need to remove the relevant expansion slots for our graphics card. Now I've got a triple slot card. That means I need to remove 3 slots for it to fit. And when we look at the expansion slot in our motherboard, it lines up with the top slot. So that means I'm going to need to remove the first, second, and third expansion slot to allow our graphics card to fit. So with the thumb screws out, the brackets, you just need to pull them forward and they should be easy enough to remove. The other thing to check before installing your graphics card is that the GPU support bracket is all the way at the bottom. If we had this installed higher up, it might interfere with our graphics card. So we want to keep it at the bottom and only bring it up once our graphics card has been installed. So next thing we want to do is line our graphics card slot up with the slot on the motherboard and line the bracket up with the expansion slot brackets. So we'll slide our graphics card carefully into place, and we'll just look in and see how we got it lined up correctly. Might require just a little bit of wiggling about. I can feel that that has gone into the slot. Once we're happy it's going into the slot, it's just going to be some firm pressure to the graphics card, and you hear it's going to clip into place. And because this is quite a large graphics card, we're probably going to want to just support it a little bit until we've got the thumb screws back into place. So we'll replace the 3 thumb screws that we've just removed. So not so easy for me to get you a good shot of this, but whenever I try to lift the GPU support bracket up, you'll notice that our USB Type-A cable is getting in the way. So I'm going to temporarily unplug it, and then I'll try and get it plugged in again at the end once we've installed the GPU support bracket. And then we can just slide the bracket up to where it supports our graphics card. Now we are going to want to have it positioned where it's not getting in the way of the fans. So it's not so easy for me to get you a good shot of this, but no matter which way I turn the bracket, I'm only able to get one of these little pads. There's 2 pads on it onto a part of the bracket, and then the other pad is actually then sitting in the graphics card. So I am going to struggle to use this bracket. Installed there, the back bit is supporting the graphics card there. But then when the fan goes round, the fan catches in the other side of the bracket. So what I'm going to do, I'm going to temporarily remove the bracket from the case and see what I can do to fix that. So the bracket's held on at the back with these 2 screws. And then we can slide this bit along this way. And the bracket's then simply going to fall out. Okay, so that's our bracket now outside the case, and like I say, no matter which way I managed to screw it, I was able to get one of these into the right place, but then the other one was sitting into the fan, and if I turned it over the other way, then the other one was getting into the fan. So let's have a look. We've got a little rubber pad here which we can pull off, and it looks like there is just a screw going through the other end. So let's see if we can open this bracket up, and if we are able to remove this little pin, it should work okay. No, so that really hasn't helped things. This just looks to be a single bit of plastic. So what I'm going to do, I'm going to cut this off, and then we'll just leave one end of the support bracket in place. And in fact, I was able to get it nice and completely flat with just a knife. So hopefully now, when this bit is supporting our GPU, we won't have this bit here sticking in our fan. So I'll go ahead and reassemble this and get it back into the case. Okay, so we'll try that again. So I'm just going to try and position at the middle of the bracket. So I'll tighten the bottom thumb screw to hold it in place. And then I'm just going to push backwards to get our 1 thumb screw sitting at the back of the graphics card. And then as we lift up, that's sitting quite nicely there, and the front isn't in the way in the fans. So all we're going to need to do now is tighten the 2 screws at the back to hold that in place. So I'm just lifting this up at the front, keeping it in place while I tighten these screws. Okay, so just have a quick look at that. We can see that the little rubber pad is sitting all the way at the back of the graphics card. There's no pad on this one. When we spin that end fan, it's spinning completely freely. So a very important check, anytime you use a GPU support bracket, you're going to want to check the fans underneath it to make sure it's not obstructing it. So the last thing I've got to do is try and get our USB Type-A cable plugged back in again. It doesn't look like the easiest job, but there is a little bit of space now below our bracket to bring it in. So we'll just bring it through the end hole so we've got a little bit more room to work with it. And we'll get it lined up with the header and push into place. And then we'll just pull the excess cable through to the back. So that wasn't the easiest to do, and it's not the cleanest looking cable, but it all should work okay. So you can see the GPU support bracket is doing a good job of supporting our graphics card. It's lovely and straight. And when you go with such a large graphics card, the GPU support bracket isn't really an optional extra, it is really an essential. But with that modification, it seems to work fairly well. You would just have to be careful if you were moving the case about. When you put it back, you'd want to check everything was sitting correctly. Next, we just need to bring our 12 volt 2x6 cable through the rubber grommets at the bottom. We're going to line it up. Remember, it only goes one way, so take a wee look at the connectors in your cable to make sure you've got it round the correct way. Go ahead and line it up with the graphics card. And once we're happy everything's lined up, some firm pressure, and we are going to want to make sure we get a nice satisfying click when it goes in, and a good look around, making sure all the blue has disappeared. It has, meaning that we've got it properly plugged in. We do have some cable combs on these cables, so we'll use these to help organize the cables. So at this stage, all we've got to do is some cable management to get our panels back on again. But you can see we've got loads of Velcro straps and cable racewise, so this should be fairly straightforward. So we can just free up the Velcro straps, and then we'll pop them around our cables. We've got this extra 4-pin connector from our EPS cable, so we'll just tuck it in here out of the way. And then any of the excess cable we can just push in out of the way at the bottom. And then at this stage we can go ahead and replace the side panel. And we can replace our top fan stroke radiator bracket. Just slide it straight down and then push it back to lock into place. And we'll secure it at the top with the 2 screws. And we can set our top panel back into place. So just before we put our tempered glass panel on, we're just going to free the plastic peel up from the bottom of it. And then we can set the bottom bit of tempered glass down into the case and push it up to lock it into place. Then it's just the 4 screws to replace at the back. And then it's time for the peel. So we've got one more step before we can power our PC on. We need to make a Windows 11 bootable USB drive. So you're going to need a blank USB drive because anything on it is going to be wiped during the process with at least 8 gigabytes of storage on it. And you're going to need another computer to make this on. So I'm going to go ahead and plug this into the computer. And you're then going to want to head over to the Download Windows 11 page. You'll find a link to this in the description. We're going to go down to Create Windows 11 Installation Media and click on Download Now. We can open it. Click Yes. We'll accept the terms. So it's found English, United Kingdom and Windows 11, which are the options that I want. If I want, I can change those by on-clicking here, and then it's going to give me the option to change things in the pull-down menu. But these are the right options for me, so I'm just going to click Next. And what we want to do is make a USB flash drive. So we'll leave it on that option and click on Next. It's found the external drive that I have got plugged in. So you're just going to have to select where you want to install this. I'm going to click Next. And this is just going to take some time. Okay, it says your USB flash drive is ready. We can go ahead and click on Finish. We can then eject the drive. And we're ready to move on to plugging this into our PC. Okay, so we can take our USB drive and plug it into the back of our new PC. We can plug the power cable from our power supply in. And importantly, we're going to want to turn this to on. We need to plug a HDMI or DisplayPort cable into our graphics card, not the port on our motherboard. And we'll plug the other end into a monitor. If you're planning on using Ethernet, we'll plug it in as well. We've got the antennas for our Wi-Fi and Bluetooth. They simply clip into here. This is magnetic, so you can set it anywhere on the back of your PC and it will stick. And then we just need to plug in our keyboard and our mouse. So we now reached the moment of truth in any PC build. It's time to flip this power switch and see have we done everything right and will our PC post. So here it goes. So that's a good sign. I can hear the fan spinning. I can see the screen is lighting up on our graphics card. So all we're going to have to do is watch the monitor and see if we get a post. So if your PC doesn't power on or post, don't worry, I've made a video that covers the common troubleshooting steps and you'll find a link to that video in the description. Oh good, so we've got our post. So what we're looking for now, because we have nothing installed in our SSDs, we're hoping it's going to find our bootable Windows drive and boot off that. So if that's the case, the next thing we should see is the Windows installation screen. So perfect. So what I'm going to do now is to show you how to install Windows 11, but to make it a little bit easier, I'll switch over to the screen mode. So as we go through the following screens, I'm going to click the options that are relevant to me. If different options apply to you, click the ones that apply to you. So I'm going to click on Next, Next, and I want to install Windows 11. So I'm going to agree to the terms and click on Next. So if you've got a Windows 11 license, you can put it in here. If you're going to get one later on, what you can do is click I don't have a product key. Select the version of Windows that you're going to get a product key for in the future. So I'll select Windows 11 Pro and click on Next. I'm going to accept the terms. And then we're going to have to select where we want to install Windows 11. You can see it's found 3 drives. So the 500 gigabyte drive, that is our SATA SSD. We've got our 2 terabyte NVMe drive, and we've also got our USB drive where we've installed Windows 11 and it's currently running off this, and we've also got some allocated space in it as well. So we definitely want to install this on our Gen 5 NVMe drive, so we'll go ahead and select it. And I'm going to give you a tip here. If you've got multiple drives of the same capacity, for example, you had two terabyte NVMe drives and you wanted to put it onto a particular one, what I would advise you to do is just install one of them at the start, go ahead and install Windows on it, and then you can install the additional drive at a later stage. The reason is there's no way here to distinguish one drive from the other, and if you want to install it on a particular one, it'll be very important that you just have that drive installed. Obviously with different capacities you can tell which drive is which. So we'll go ahead and click on Next, and we'll click on Install. So this next step will take some time. Okay, so that's Windows installed. We just need to set it up. So I'm going to select United Kingdom by clicking yes, and yes again. I'm going to skip a second keyboard. So we're going to need to name our device. So I'm going to call it BF360 and click on Next. It's going to restart. So I'm going to set it up for personal use, click Next, and then we're just going to check for updates. So I'm going to sign in with my Microsoft account. We'll click sign in. If you don't have a Microsoft ID, you can go ahead and create one here and click on Next. So I'm going to send a code to my email and I can type that in. So I need to create a PIN, so I'll go ahead and create that and click on OK. So then you just need to pick the options that you want. So I'm happy for Microsoft to use my location, click accept. Find my device, yes, accept. I'm going to click required only, accept. Inkling, no, accept. No, accept. So we've now got the options to restore the PC from an earlier backup, but I want to set this up as a new PC. So I'm going to click on more options. You can see all the PCs I've set up in the past, and I'm going to go set up as a new PC and set up as a new PC. I'm just going to click skip here. Okay, and that's us through to Windows. Now we are getting a pop-up set asking us, do we want to download and install Gigabyte Control Center? Now we are going to need this software to control the RGB on our graphics card and also to allow us to set up the screen on our graphics card. So I am going to click on install to save me having to find it later on. But if you're wanting to run your PC without any software, for example, you've got a different graphics card which doesn't require any RGB package, I will show you how to install drivers without the Gigabyte Control Center. So I'm just going to click install now for convenience, and we'll let it install. So we're just going to accept the license terms, and I'm going to come back into this later on. So the first thing I want to do is get Windows fully up to date. So we can go down in the Windows icon, click on the settings, we'll go down to Windows Updates, and we'll click on check for updates. So it's probably going to find some updates that we haven't found before. What I'm going to do is install all the updates that are available. We might need to restart our PC to allow them to install, but we're going to keep coming back here until there's no further updates available. Okay, so that's Windows fully up to date. Whenever I click on check for updates, it's telling me there's no more updates available. So the next thing I'd like to do is get all our drivers installed. So if you are going to be installing Gigabyte Control Center for RGB control, this is the easiest way to install the drivers. But like I say, if you've installed a different graphics card and you don't need any RGB software, I will show you how to install them from the motherboard page, and you'll find a link to that page in the description. Okay, so we're going to head over to our motherboard page. We're going to click on the support tab, and you can see here we've got a whole range of different drivers. Now what I'll do is I'll show you how to install some of the drivers that we're going to want. So if we have a look here, we're going to want our HD audio driver, we're going to want all the chipset drivers, we're going to need the LAN driver, we're not going to need RAID, so we can leave those out, but we are also going to want the Wi-Fi and Bluetooth drivers as well. So if I pick one of these to show you how to install it, so we'll go for the HD audio driver, click on download. The folder is going to download. We can then head over to our downloads page. We'll right click on it and go for extract all and extract. We can then double click on the application, click on yes. Okay, so that's the driver installed, and it would just be a simple matter of repeating the steps for all our other drivers. But what is much easier is to use Gigabyte Control Center, so we'll go ahead and open it up, and we're going to click on the Update Center. Okay, so we're just going to have to check that we're actually wanting all the things it's going to install, so we definitely don't want Norton Internet Security. I'm going to install all the components of the Gigabyte Control Center, and in terms of the different drivers, I'm just going to leave all these selected, but I don't want the Smart Backup or Ryzen Master. So just selecting all our drivers and all the components of Gigabyte Control Center, and we can click on install and yes. And one of the nice things is we don't have to do each of these individually. It's just going to go ahead and install everything for us. So I think it's just updated the control center as the first one. That's why it's restarted, and we'll click on install to continue installing the rest of these. Okay, so that's all our drivers installed. I will come back to Gigabyte Control Center later on to show you how to set up the RGB and our GPU screen. We'll close it for now. There is one more driver that we're going to need, and we're going to need to head over to NVIDIA's page to get the driver for our graphics card. And again, you'll find a link to this page in the description. Okay, so it's the NVIDIA app that we're going to need, so we'll click on Download Now, and then we can click on Open File. Click Yes, and click on Agree and Continue. So now we need to select our driver preference. If you're using your PC mostly for gaming, click the Game Ready driver. If it's mostly for content creation, click the Studio driver. So I'm going to set this PC up for gaming, so I'll click the Game Ready drivers and click on Next. You can choose whether you want to optimize your games and creative applications. It's up to you, either turn it on or turn it off. Click on Next. And if you want to use the NVIDIA overlay to record screenshots or game footage, you can again leave this on. So I'll click on Next. I don't want to log in, so I'm just going to go ahead and skip to the app. And then we're going to want to download our drivers. So we click on the Drivers tab, and you can see there's a Game Ready driver ready for us here. So we'll click on Download. And then we can click on Install. Click Yes. And I'm just happy to go for an express installation. This is the first time I'll install it, so click on continue. This will take a little bit of time, and it is normal for your screen to flicker during the installation, so don't get alarmed when this happens. And we're going to have to restart our PC, so we'll click on restart now. Okay, so that's all our motherboard and graphics card drivers installed. The next thing I want to do is head over to the BIOS and show you how to update it and adjust all the BIOS settings. So we're going to go ahead and get the latest version of the BIOS so we can update it if we need to when we get into the BIOS. So again, we're going to head over to our motherboards page. We're going to click on the support tab. And this time, instead of the drivers tab, we're going to click on the BIOS tab. Just while we're here at the Gigabyte Control Center, you would have found it in this utility tab if you were looking for it. It's just here if it didn't get that pop-up at the start. So we'll go to the BIOS tab, and what we're looking for is the latest stable version of the BIOS. You can see we've got all the versions from version 1 to version 9. So it doesn't look like there's any beta versions here. These all look like full versions of the BIOS. So we can go ahead and download it. We can then head over to our downloads folder. I'm just going to right click on the BIOS file, click extract all, and click extract. And it's this file here that is our BIOS file. So what I'm going to do is plug an external USB drive into the PC. I'm going to copy this file. I'm going to click on our external drive and paste it onto it. There we go. So we can go ahead and close that down. What we're now going to want to do is restart our PC. And as we restart it, we're going to want to keep pressing the delete button, and that will take us into the BIOS. Go ahead and click on the Windows icon, click on the power button, and we're going to click on restart. Whenever the screen goes black, we're going to start pressing the delete button on the keyboard. Okay, so I'm pressing delete now. And that has taken us into our BIOS. Taking a look at our BIOS, you can see we're running the very first version of the BIOS, F1, and it does go up to F9, so it probably is worth us updating things. There is a whole lot of information here. I'm going to come back and talk you through it later on, because any settings we change in the BIOS now will be wiped when we update it. What we're going to want to do is head over to the advanced mode. We're going to click on the Q flash down at the bottom, or we can press F8 to get into it. So we're going to have to select our BIOS file, so we can click on the USB drive, and it's found our version 9 of the file here, so we can click on it. We can click across here, and we can go ahead and click on yes to update the BIOS. Now, before I do this, there's a few important things to say. In general, if your PC is running well, you shouldn't really update your BIOS unless you're getting new features with the BIOS that you actually need, because there is a chance when you're doing this, you can actually brick your motherboard. What's really important that your PC does not lose power during the update, or there's a reasonable chance your motherboard will be bricked. So leave it alone. Don't do this if there's a chance that your power can go off, and stay well away from your PC while this is happening so you don't unplug something. I'm doing it today because it's reasonably out of date. You can see our BIOS version is all the way back in 2024. So it probably is worth doing this, but there is a risk every time you do this. So I'm going to go ahead and click on yes. And then we can click on ready to reboot. So this is just going to take a little bit of time, but whatever you do, stay well away from your PC, don't touch your keyboard and mouse, and don't risk unplugging anything. Okay, so our PC has restarted to Windows. It's fairly normal that you will have to reset up your PIN when you update your BIOS. So I'm going to click on set up my PIN, and it's going to want me to sign in again. So I'm going to click on that. I'll get a code sent to my email. I can put the code in, and I'm just going to have to reset up the PIN and click on OK. And now that we've updated the BIOS, we're just going to go back to the BIOS again. So we can right click here, click the power button and click on restart, and we're going to repeat that process and go into the BIOS and make our adjustments in terms of our settings. So the screen's gone black, we can go ahead and press the delete key. And that's us into the BIOS, and you can see it's had a bit of a UI change with that software update. So heading over to the side, you can see that we have updated the BIOS. The version is now running F9. And there's actually quite a bit of information that you're going to get on the BIOS screen. So we can see our motherboard, the software version, which CPU that we've got installed, how much RAM we've got installed, and we can see our RAM down here. So it is Kingston 16 gigabytes. And remember I mentioned to you that the RAM won't run its maximum speed out of the box, and we are going to have to set up the profile. So I'll show you how to adjust that in the advanced settings in a minute. We've got our CPU frequency. Importantly, we've got our CPU temperature here, so we can see that our CPU temperatures are absolutely brilliant. It's lovely and cool. We've got our motherboard temperature here as well. We've got some information on what our fans are currently running at, and we're going to be able to adjust the fan curves from here. And we can see the drives that we have installed. So we've got our NVMe drive, but over here we have also got our SATA drive as well. So loads of information on that home screen. So first thing I want to do is enable our XMP profile. So I'm going to head over to the advanced mode, and we can click on XMP Expo profile, and we'll select XMP1. So we can see XMP1 is telling us what it is. It's increased the voltage, and we're now running at 5200 mega transfers per second. So a little bump from the 48 that we were on. And like I said, this wouldn't be the kit of RAM that I would recommend buying. It was one of the very first kits of DDR5 that came out to me. Again, it was in short supply at that stage like it is now. And you can see the timings aren't great on it. There's a much faster kit of 6000 mega transfers per second and a latency of 30 rather than 40. So that would be the one that I would recommend. This kit of RAM, it only runs in XMP. It doesn't have the Expo enabled on it, whereas the other kit that I'm recommending has XMP and Expo. So in general, as I've mentioned, with an AMD system, you're better to buy the Expo RAM, but you can see here we're running an XMP kit of RAM and we're getting the advertised speed, and that does tend to happen most of the time. Okay, so the other thing I want to do in our settings is check that we've got the resizable bar turned on. So it's in the I/O ports, and if we scan down here, resize bar support is enabled. If it's turned off, you can go down here to enable it, and that's just going to allow our system to make use of our GPU's memory. So that tends to be all the things I'm going to change in terms of the settings apart from our fan curves. If you do want to turn secure boot on, it's over in the boot tab. You can click on secure boot, and then you can click on enable. So the other thing that I want to do then is to go back and adjust our fan curves. So the easiest way to do that is just to go back to the easy mode, and we'll click on our smart fan. So we start off with our CPU fan. CPU fan speed control is set to normal. If, for example, we want just to enable a different profile like silent, we can do that. And that is going to slightly change our profile. We can change the source of temperature, so it makes sense to leave it on CPU. The other thing we might want to do is adjust the control. So it's currently set to auto, and what it will tend to do is detect whether it's got PWM fans enabled, and if it does, it will run them in PWM mode, and if it doesn't, it will run them in voltage mode. What we can do is just enable PWM ourselves to avoid any confusion. And we've got the CPU fan stop, so we definitely don't want our CPU fan stopping at any stage, so we're going to leave that on disabled. So you can see now those changes have brought our idle noise down a little bit, and our CPU fan speed has decreased. So the other thing that we can do is set up our own custom fan curve if we want to take things a wee bit further down. So we can click on the manual, and then we've got the option to either drag these points to where we want them to be, or we can just change things in the text at the bottom. So I'm going to set up, I have a standard fan curve that I tend to run. And you can see that sort of gives a more gentle fan curve. So that would be what I would tend to run on most of my systems, and I find it works fairly well. Okay, so we'll head over to System Fan 1 as well. And you can see it's running much faster than what it actually needs to be. So again, we can customize this as well. Now we can see it's running on the normal fan curve. Again, I'm just going to go for the manual fan curve and set up the same values that we had for the CPU fan. So that's our system fan curve set up the same way as our CPU fan curve. Now the only difference is it is running off our system temperature, which is currently 25, and it won't vary quite as much as our CPU temperature. Now this is generally the way I tend to set these fans up. I like get them to run off the system temperature, because if you have everything running off the CPU temperature, anytime your CPU increases a little bit, what will happen is all the fans in your system ramp up and ramp down, and it can be really annoying to sit beside. So I'll set this up, we'll do some thermal testing and check the PC is happy running like this. And there is always the option if you want to change this to your CPU temperature, but be warned, any increase in CPU temperature and all your fans will increase. Better for cooling, but not so good for noise. We're currently running in the auto mode, so I'm just going to change this over to PWM. And again, we don't want these fans to be stopping. Okay, so that's all the changes made that I want to make. So I can go ahead and click on the escape key. We click on save and exit. It's going to give us a summary of all the things we've changed, including enabling our XMP profile and adjusting all our fan curves, just to see all the changes that we have made. We can click to save our settings, so we'll click yes, and then the PC will reload it into Windows. So one thing I'm noticing, the PC was lovely and quiet, and then when Windows loads up, the fan noise has increased a little bit. And that is because Gigabyte Control Center will take over the fan curves once Windows loads. And I hadn't realized this in previous videos and couldn't understand why the BIOS settings weren't controlling the fans. So there is a fan control mode in Gigabyte Control Center, so we'll go ahead and click on it. And it is mostly for setting up your GPU fans. We'll just skip the tutorial. But it is also possible to set up our motherboard fan curves here. So we click on the motherboard, and at the moment you can see the fan curves that we are currently running on our CPU fan. And that's the thing, once Windows loads, the fan curves in Gigabyte Control Center are going to take over. So all we're going to have to do is set up our two fan curves exactly the same way that we had done in the BIOS. So we're going to set up our CPU fan first of all, and we'll just set up exactly the same points that we had done before. So not quite as nice to adjust here as we don't have the boxes to type into, but I have dragged the fan curves roughly to where they were and click on apply. And that's going to then get our CPU fan running along this fan curve. We'll just have to do the same with system fan 1. So it's currently monitoring off the system temperature, and we'll just set up a very similar fan curve. Okay, so you can see the difference between our new curve and our old curve, and when we click apply, the fan will run over onto that new curve. So obviously we will have to do thermal testing to check that these temperatures are okay and the noise in the background has gone down since we've made these changes. So we now want to check that our changes in the BIOS have been made in terms of our RAM speed. So we can do Control Alt and Delete, click on Task Manager, and we're going to click on the Performance tab. We're going to click on Memory. And what we can see is that our RAM speed is up to the 5200 megatransfers per second that we wanted it to be. We also just want to check that the resizable bar is turned on. So we go down to the settings, right click on the NVIDIA icon, and it's the NVIDIA control panel that we want. We'll click agree and continue, and we click on system information. And we can see that resizable bar has been enabled. So we'll click on close. Okay, the next thing I want to do is show you how to activate Windows once you've got your product key. So we're going to click on the settings. We'll click on the system, and we can go down to activation. So you can see that Windows 11 Pro is activated with a license that's linked to my account. If you haven't done this yet, you just need to go to change product key. So we'll click on change, and this is where you're able to put your product key in to activate Windows. So I'll click on cancel here. The next thing I want to do is adjust a few of the Windows settings. So the first thing, whenever I click on the file icon, it brings up the quick access. I would rather it just brought up this PC. So I can click on these lines here, click on the options, and rather than home, we'll just change this to this PC. Click apply and OK. So now when I close this down and I click on the file icon, we're right on this PC. So the reason I had installed the SATA drive was I wanted to show you what happened when you install multiple drives. And in general, only the drive that you install Windows on will be detected when you first install Windows. So what we're going to do is head down to the search icon, and in the search bar, we're going to type in disk management. And what will happen, create and format hard disk partitions comes up. So we'll click on it. So you can see our C drive, this is where Windows is installed, but we also have this unallocated space on our SATA SSD. So we need to right click on it, click new simple volume, click next, next. We can change the letter here if we want to. I'm going to leave it as D. Click next, and then we can just change the name. So I'm going to call this SATA SSD and click on next and finish. So it's going to go ahead and format the drive, and then you'll now notice that we have the option to enter our SATA drive in this PC. So there's some other things I'd like to get rid of. You can see the OneDrive is here. I don't want this, so I'm going to pause the syncing and quit the OneDrive. The problem is whenever I open up Windows again, the OneDrive is going to start up again. So what I'm going to do is go in Control Alt and Delete, go into the Task Manager, and this time we're going to go into the Startup tab. So these are the apps that are going to load up at startup. So OneDrive, I can right click on it and click Disable. And the other program that we've got here is our Radeon software. So this is one of the drivers installed by Gigabyte Control Center. It's for our integrated graphics in our CPU. So we don't really need this because we're using our graphics card. So I'm going to disable that as well. And then we can close this down. The other thing, I like to customize the start bar, so we can click here and go to taskbar settings, and we can turn off things like the widget. For the search bar, I just like to have the search icon, so that's looking a little bit cleaner already. And if you want to change your background, just right click on it and click on personalize. And for example, if you just want the standard Windows icon, if you want to turn dark mode on, you can do all of that from here. And of course you can upload your own custom images. Another thing we're going to want to check is that we're running the right resolution. So we can click on here, go to our settings, and we'll go to System and Display. So you can see here I'm running 1920 by 1080. That's because I'm recording through the ATEM Mini Pro, and that is what it's picking up as my output. The other thing you're going to want to do is check your refresh rate. So I can go down to here. And at the moment, again, I'm running 60 Hertz. And again, it's because I'm going through the ATEM Mini Pro to record my screen. So when I plug into my monitor, you're going to want to go into here and just check that you're getting the best refresh rate that you can for the screen that you're using. The next thing I want to do is show you how to set up the RGB on the system. So we'll load up Gigabyte Control Center. And we can click on RGB Fusion. We've got all our different RGB headers, and we've also got some lighting on our motherboard. So if we want to control each of the headers separately, we can, and the lighting on the motherboard we can control as well. If we want just everything to be controlled together, we just need to click this sync button, and then we've just got the one option to change things. Now there is only a little bit of lighting on the bottom of the motherboard because we've got nothing plugged into any of the headers, and I think it would look much cleaner if that was turned off. So I'm going to click the off button, and you notice that lighting in beneath our graphics card has now gone off. So that means that the only thing that now has lighting on it is our graphics card, and we've got a variety of different areas on our graphics card. So you'll notice there is a little bit of lighting on the top of the graphics card just beneath our CPU cooler. We've got the lighting on the front of the graphics card, and we've got the lighting on our fans. So there's no lighting on the fans at the moment because the lights only come on when the fan starts spinning, and our fans have a zero fan mode, so when there's low load, the fan stops spinning. So again, I do have a way that I like to set this up. So let's have a look. So there's the off button. So that is everything turned off at the moment, and if we click apply, you'll notice that all the lighting on our graphics card has gone off apart from our screen. So what I do like to do is set a static white. And I'd like this everywhere normally apart from the fans. So if I just click on the fans, this is going to turn them off. And where I do want the white is on the Aorus logo at the front. Okay, so the next thing to do is set up our LCD panel, so we can click on it. And you've got a whole variety of different options for the display. So it's currently set up to Enthusiast 3. We can try Enthusiast 1, 2, 3 is the one that I prefer. And you have the option to upload your own custom images and files to be displayed. And at the moment it's on a carousel, just cycling through all our different system information, each for 3 seconds. And again, there's the option to adjust the interval that each item is displayed for. So I'm just going to leave that on as standard, but feel free to make changes here if you prefer. Okay, so the other thing I want to do is show you fan control on the graphics card. That's the only thing I haven't shown you. So there is the option to adjust the fan curves on your graphics card. At the moment, it's running in the auto fan stop mode. You can see here, temperatures are going to have to hit about 55 degrees before the fan comes on, and then it follows that curve. If we turn for customized mode and turn the auto fan stop off, you'll notice that the fan will run all the time. And if I click apply, we'll notice some noise kicking up in the background. Our fans are starting to kick up in terms of speed, and they're going to run all the time. I wouldn't recommend doing this. I'm quite happy with the fans only coming on when they need to, but this is how you change things if you want to. So I'll just hit the default button and click on apply. So that's the PC running great and looking great, but we do need to check its temperatures, and this would be something I would recommend you do on any new build. So the program I tend to use is IDA64, and they do offer a free trial, so we'll go ahead and get it downloaded. So we can head over to the Downloads tab in IDA64, and we're going to download IDA64 Extreme. So we'll click on Download, and we'll go ahead and download. When it's installed, we'll click on Open File, click Yes, and OK. We'll accept the agreement, click Next, 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 and Next, and Install. And we can click to launch IDA64. Click Yes. So we get 30 days to try this out, which is perfect for testing a new PC. So we'll just click on OK. And it's the thermal stability test that we want to run. So we'll click on the fire icon, and we can just maximize this. So we're also going to want to stress our disks and stress our GPU. So the first thing is to get everything showing up that we want to show up in our temperatures. So we're going to click on the preferences. So under the yellow, I like to have the CPU diode, and green is when I tend to have my GPU1. Now the GPU1 is our NVIDIA card, GPU2 is our integrated graphics. So we can just label everything else, fill it in. Okay, so we've got everything filled in under the temperatures. In terms of our fans, we've got our CPU fan. We're going to have chassis fan 1, which is the fans in our fan hub, and then we're going to have our 2 GPU fans. We can disable this one. Voltages, powers. The other thing I quite like to look at is the clock speed. So we've got our 8 clocks of our CPU. Other things we can add in. We can add our GPU clock and our GPU memory clock. And click on OK. And on the graph, there's an awful lot here. I tend just to look at the CPU diode and GPU temperature. So I'm just going to disable all these other ones. It'll still record them, but they won't show up on our graph. So we've just got the 2 items showing up here. So just before we do the thermal testing, I want to see how good a job we've done compared to the same hardware in another system. So I recently did a build in the Lian Li Vector V100 Mini, where I used exactly the same CPU and exactly the same GPU. So you can see the CPU idled at 41 and reached a maximum of 68 degrees during the 10-minute IDA64 stability test. And our GPU idled at 30 and reached a max of 62. Noise levels weren't great in that build. I can remember building it and thinking it was really noisy. So it idled at 45, which is really high. And under load, it was all the way up at 60 decibels. So not the best in terms of noise. So I think definitely today we will have done a better job. I am expecting our CPU temperature to be a little bit higher under load because that system was cooled with a 360mm IO. I'll just put a little bit of footage of the complete build. So you can see exactly the same GPU set up the same way with the same colors. Here we have fans on the side bringing air in. But up top, rather than our air cooler, we've got our 360mm AIO and 3 fans at the side bringing intake. So I'm anticipating my CPU temperature will be a little bit higher, given that we've got an air cooler versus a 360mm AIO. But I think my GPU temperatures might be slightly better, and I think noise levels are going to be absolutely destroyed by the system that we have built here, because that was a big focus on what I have built. So let's go ahead and run the thermal testing and see how good a job I actually have done. Okay, so to start our stability test, we can go ahead and click on start, and I tend to run this for around about 10 minutes. So you can see already we've got 100% load on our CPU, and we'll just watch and see what happens with our temperatures. So both our CPU and GPU temperatures are increasing. Okay, so just about a minute or so left of this test to go, and things do look like they've been leveling out. So let's go ahead and take a look and see how things are going. So maximum CPU temperature up at 67 degrees, and it was 68 with the 360mm AIO. So this brand new Noxia cooler is performing really well. GPU temperature is 59. That is 3 degrees cooler than what it was in that other system. So this case is doing a great job in terms of airflow. And I can actually barely tell that the system is under a load, because noise-wise it's only 33 decibels recorded 30 centimeters away from the closed tempered glass panel, compared to 60 decibels in that other system that I had built with the same CPU and same GPU. So very impressive results. And the other thing I forgot to say is our chassis fans are still running nice and slow. CPU fans have kicked up to 1100 revs per minute, but we're only running in the 500s, our system fans. So they're pushing a lot of air at low speeds, which these large fans are designed to do. Okay, so that's the maximum temperatures, 67 and 59. We can go ahead and stop the stability test. What I normally do is let the PC idle now for 10 minutes. So let's see, I normally have the fans running during this test on the GPU. So I'll hit a fan control. We'll go for a customized mode, and we'll just turn that auto stop away so that the fans are running. So we've been idling now for about 7 minutes, and you can see the CPU temperature falling down from where I started and GPU temperature falling down. We head into our statistics. You can see we've had a minimum temperature so far of 43. That is 2 degrees above the AIO's minimum temperature, but still pretty close. And our GPU's hit 27, which is 3 degrees cooler than what it was in the other system. Again, noise is massively reduced. The average noise at idle is only 30 decibels, which is a massive 15 decibels beneath the other system. And that was my biggest aim, to build a PC that was whisper quiet. And there's actually only 3 decibels of extra noise when the system's running. And you can see the big reasons for this. Our CPU fan here running in the 500s, where it only reached 1100 under load. And our chassis fans haven't really changed, because they're reacting off the system temperature, which isn't really changing, and that's why we've got a lovely, quiet and pleasant system to be beside. So that's our PC fully set up, looking absolutely amazing and running cool and quiet, and I'm absolutely delighted with how everything came together. What I set out to do in this build guide was not to build a PC with all flashy fans, lots of lights. I wanted to build a PC that I would actually build if I was building for myself, not one for the YouTube studio with all the fancy lights and fancy fans with lots of software required to run it. I wanted to build a PC with the minimal amount of software, with good quality, quiet components. So hopefully you have enjoyed this beginner's guide to building a PC. If you have, please do me a favor and hit that like button. And if you're not currently subscribed to the channel, please hit the subscribe button as well. And drop me a comment and let me know how you get on with your own PC build. Thanks for watching.